this class, we will discuss about the expressions of concentration. There are different expressions for concentration of a given solution. Let me consider sodium chloride solution. This sodium chloride solution can be represented in various concentration terms. Like we can have percentage of concentration, then normality, molarity, mole fraction, then parts per million. So likewise, we have variety of expressions of concentration. So in percentage of concentration, in terms of percentage, this can further be classified into weight by weight percent, weight by volume percent, then volume by volume percent. Okay, right. And before entering into this topic, we should know something about the very basic idea about the solution. So, what do you mean by solute? It is a part of the solution. Solute, when it is dissolved in solvent, it becomes solution. So, solute is the smaller portion of solution. Solvent is the major portion of the solution. So, solute can be represented by 2 because it is in the second portion, second level in the portion. Whereas the prime portion, the major portion is solvent. So, we can represent this by 1. So, solvent is represented by 1. When I say weight of solvent means W1, weight of solute means W2. Similarly, when we talk about molar mass, that is molecular mass, so M1 represents the molar mass of solvent, M2 represents molar mass of solute, then N1 represents mole of number of moles of solvent, N2 is number of moles of solute. I hope this part should be very clear. Let me take a pinch of salt, sodium chloride, common salt, and dissolve in 100 ml of water. So that pinch of salt, the amount of salt, that is the weight of salt, that is represented as what? W2. And the given volume, that is, let me say 100 ml, it is the made up volume. It is not the 100 ml water then we dissolve. We take first a small quantity of water, dissolve it and make it up to 100 ml. So that is the made up solution. So when I say volume means volume of the solution. Okay, so this part should be very clear. And then you should know something about molarity. Molarity is represented as mole per liter. Mathematically, it is N2 by V. N2 by V. So, molarity, that is represented as uppercase M. M is equal to N2, smaller n, N2 divided by V. So, that represents the what? The molarity. So, molarity is equal to N2 by V. What is N2? N2 is weight by molecular weight of the solute. So, W2 by M2 is equal to N2. So, the final equation is molarity, capital M, is equal to W2 by M2 into 1 by V, where V is, that V represents volume of the made up solution. Okay, it is not the volume of water, it is the volume of solution made up finally. Do you understand this point? So anyway, that is if I write the equations, molecular formula, all these things and working out, and that will be very easier, is it not? So let us proceed with this important topic, how to express the concentration in various ways. Shall we move into the topic? Okay, thank you. So we move. So I was discussing about the concentration C. The C concentration can be represented in various ways. That is percentage concentration, then molarity, normality, and there is one more term called molality, and this is mole fraction. Okay, this is mole fraction of the solute. And this percentage can be further divided into three. That is weight by weight percentage, weight by volume percentage. If it is a solute is liquid solution, then you can put volume by volume percentage. Okay, so this is the first aspect. Okay, this is the first aspect about the expression of concentration. And second, molarity. So molarity is given by N2 by V, where N2 represents W2 by M2, number of moles of solute. So W2 by M2, and you can put 1 by V. Got it? So what is W2? Weight of the solute. M2, molar mass of the solute. V, volume of the solution in liter, remember. And this is W2 in gram. Similarly, M2 in gram per mole. And what about this? Volume of solution in liter. Okay, right. Then let us come to this. What is N? N is called normality. So this normality is represented by an equation equivalent of the solute divided by volume of the solution in liter. And what is this equivalent? This is nothing but W2 divided by, let us say, that is gram equivalent weight of the solute. Okay, so into 1 by V, because equivalent is weight by gram equal weight of the solute. Okay, then 1 by V, volume of the solution. And this can further be expressed as, that is, gram equivalent weight is nothing but molar mass divided by valency factor. So W2 divided by molar mass of the solute is M2. Okay, so divided by valency factor E. I will discuss about this later. Then into 1 by V, the volume of the solution in liter. Do you understand? Right. And let us further move. That is equal to, now W2 by, we can rearrange W2 by M2, and we can reciprocate this E to the numerator. So E by V. So this is normality. So there are various terms associated with normality. Okay, right. And we already know weight by molecular weight into 1 by V is molarity. So we can replace by another equation. How? Just follow that. We know that W2 by M2 into 1 by V is normality. Okay, so we can replace this by M. So N is equal to M, which is nothing but molarity. W2 by M2 into 1 by V is equal to molarity into valency factor. So Normality is equal to molarity into what? The valency factor. Molarity into valency factor. So these are all very important equations. And this is the relationship between normality and molarity. Okay, right. And what about this molality? Okay, this is known as molality. So this is given by, that is N2 divided by, that is weight to the solution. We can simply say weight to the solution in kg. Like in this case, volume in liter, it should be given in kg. Okay, so N2 by W in kg. And we are able to express this N2 as W2 by N2. So we can further modify this equation. Therefore, M is equal to W2 by M2 into 1 by W. Remember, this is still in kg. Okay, right. And suppose if you have used W as gram, then you need to convert this into kg. So for which you will divide by 1000, is it not? So in that case, again, M is equal to W2 by M2 into 1000 divided by, that is W. Okay, in that case it is converted into kg once again. Okay, so molality should be always expressed as what? Mole per kg. Remember this. Similarly, molarity should be represented as mole per liter. Okay, molarity should be expressed as mole per liter. And let us discuss about another expression of concentration, and that is chi2. This should be called chi, chi, chi. So chi2, what is chi2? Chi2 is N2 divided by total number of moles, that is N. Okay, so this can further be explained as W2 by M2. Otherwise, you can put N2 divided by N1 plus N2. So N2 divided by N1 plus N2. Okay, so that is nothing but number of moles. Simply you can call it N2 by N. Okay, there is one more equation, expression, that is known as it is useful in the in determining the concentration of salts present in water, that is called hardness of water, to measure the hardness of water. So this is known as parts per million. Okay, it means that is W2 divided by W, weight of the solution, present in weight of the solution, into 10 power 6. So this is called parts per million. We understand? And we will try to explain one by one, and probably that is, you may be interested to know some formula associated with the W by W, that is weight by weight percentage. So let me explain that also. Okay, so let us consider the first part, that is percentage. How to calculate easily the percentage. Okay, right. Now, so for which you need not have the knowledge about the molar mass, atomic mass, etc. Just percentage, that's all. So percentage. So percentage. Now we are interested to find out weight by weight percentage. Is it not so? Weight by weight percentage. So weight by weight percentage can be calculated by taking W2 divided by weight of the solution into 100. That is the simplest way. Okay, and similarly weight by volume. If it is not given as weight by weight, weight by volume, volume by volume, it is understood always weight by volume percentage. Okay, so that is weight of the solute given in, that is the given amount of solution in ml. So this is in ml, volume of, this is volume of solution in ml, volume of solution in ml. Okay, ml, and into 100. Okay, so this is the way you can easily handle Then volume by volume percentage means that is equal to V2. V2 means volume of the solution divided by volume of the solution in ml into 100. Okay. So this is the easiest way to have the percentage expression. Okay. So you must remember one thing, that is 2 represents, as I already mentioned. Let us consider the solution part. Solution, as I already explained in the beginning, solution consists 2 parts. Solution contains 2 parts. One is solute, another is solvent. So the solute part is represented by 2 and solvent is 1. When I said weight of the solute, W2. Weight of the solvent, W1. Molar mass of solute, M2. Molar mass of solvent, M1. So this is the way you can easily practice and adhere to this symbolic representation, so that you will not have any confusion while you solve the problem. And this is N2 and this is N1. So number of moles of solvent. So like this you can proceed. Okay, right. So let us discuss the practical aspect about the problem of what? Concentration. Okay, let me have, for example, that is calculate the percentage, weight by weight percentage of sodium chloride. Amount of sodium chloride is, that is W2 is given. Let me say about 20 gram. So 20 gram dissolved and made up to say weight of the solution. When I put W, weight of the solution, so 1000 gram, that is 1 kg. Now what we need to calculate, weight by weight percentage should be calculated. What is the formula? The formula is W2 by W into 100. That is the easiest way you can proceed. So otherwise you will be putting for 1000 gram, what is it, 100, how much? So you need not worry all these statements. Best go by algebraic formula. So W by W percent is equal to weight by W2 by W into 100. So what is W2? 2 and 20. What is W? 1000. So ensure that both of them in gram, into and 100. That is our formula. Okay, so strike. So what is the percentage? 2%. So you can declare the percentage of sodium chloride obtained from this will be 2%. Weight by weight. So this is the way you can declare the answer. Do you understand? Right. So now let me discuss what is the weight by volume. Okay, right. Go through that. Now let me have another problem. See, the same 20 gram take down. So now we are going to calculate weight by volume percentage. Okay. Now given is W2, that is the same, or you can take sodium hydroxide. Sodium hydroxide W2 is taken and I have 20 gram. Okay, and that is the dissolved and made up to say 500 ml. Let me say like this, 500 ml. Okay, now what is the percentage I can get? Weight by volume percentage. So simply you can use this equation. Weight by volume percentage is equal to what? That is 20 gram. Or let me introduce the equation once again so that it will be comfortable for you. So W2 divided by V into 100. Okay, so that is equal to, what is W2? 20 gram. What is the V? 500 ml. It should be given in ml only. So 500 ml. If it is given in liter, like half liter, then you have to convert it to ml. So 100. Okay. Now you can strike out and say, sir, this is 4% weight by volume. So you must declare weight by volume. This is the answer. Okay. So let me have another sum, that is volume by volume. So in that case, V by V percentage. Let us calculate. So the volume of the solute, like say we can say milk. Okay. So the volume of the solute is given as 10 ml. Okay, or 100 ml. It is dissolved and made up to, okay, this is V2, dissolved and made up to 2 liters. Okay, now what is the volume by volume percentage? Okay, now let us calculate what is the equation. V by V percentage, that is equal to V2 by V into 100. Okay, so let us proceed. What is V2 here? 100. What is V? It is 2 liters. So that should be converted into ml. So 2000 ml. Okay, so we have 100 ml dissolved and made up to 2000 ml into 100. Okay, now let us cancel it. Okay, now it is 10. So 10% volume by volume is equal to 10%. So that is the way you can, I'm sorry, that is 5% because you have 2. So you can cancel this 5. So 5% volume by volume solution. Do you understand this? So this is regarding the percentage. Are you able to follow? Right. Now let me move to the another one, that is molarity. Okay. Let us take up this molarity. For molarity, here the problem starts. That is, you should know something about the molar mass. Without that, you cannot do. Okay. So molarity. Okay. Right. Molarity is represented as M. Is it not? Molarity is represented as M. Let me have M is equal to, what is our formula? N2 by V and W2 by M2 into 1 by V. You should note down that V is volume of solution. What is that? Volume of solution in liter. Remember this. So you had to convert this. Therefore, now let us go through the problem. I have, say, about 5 gram, okay, 5 gram NaOH, 5 gram NaOH dissolved and made up to, say, about 500 ml. Let me say like this. Okay, this is the resultant solution. So volume of the solution is V. And what about this? W2. And we need one more parameter. What is M? So that need to be calculated. And this should be converted into 500 ml should be converted into liter. Is it not? So that is half liter. That is 0.5 liter. Then and M2 we require. So W2 is given. V is given. M2 is required. So we have to calculate the M2, which is nothing but NaOH. So for sodium it is 23. For sodium it is 23. For oxygen it is 16. For hydrogen it is 1. Therefore it is 40. So you should always express the molar mass in the respective unit. So 40, you can call it gram per mole. Okay, so this is a unit per mole. So 40 gram. Okay, now we have all these values. We can simply calculate molarity. So molarity is equal to W2. What is the weight given here? It is 5 gram. So 5 gram W2 5 gram and then divided by molar mass 40 into then 1 by this is M2 means N2 by W2 by M2, that is N2 divided by 1 by liter. This is 1 by 2 liter, that is half liter. Is it not? So you can put 5 divided by 40. You can reciprocate it. So 2. That is equal to 10 divided by 40. So strike out, that is 0.25. What is the unit? Mole per liter. So you have to mention like this. So this is the molarity of sodium hydroxide. Do you understand? Right. Now let us calculate the same thing in normality. Okay. So what is the normality of the above solution? N is asked. What is the formula? N is equal to W2 by M2 into valency factor divided by V. So we already know W2 is taken as how much we have taken? We have taken 5 gram, is it not? 5 gram NaOH and 500 ml solution. So 5 gram NaOH. NaOH is 5 gram, 5 gram, and M2 is 40 gram per mole, and what about that is the V is half a liter, and what is the valency factor for sodium hydroxide? So you have to consider the OH minus ion and Na plus. So it has a tendency to release OH minus ion, one OH minus ion. So its valency factor is 1. Let me explain valency factor in detail subsequently. So here E is equal to 1. Now let us put N2 by W2 by M2. So the same equation, 5 divided by M2, 40 into 1 divided by, and volume is 1 by 2. So 1 by 2 means reciprocator, so 2. So again, so this is how much? 20. So that is 1 by 4, that is 0.25. So how to represent this? Equivalent per liter. So this is the way you have to represent. So one thing you can find, in this case normality and molarity both are same. Why? Because the valency factor remains same. So this can be achieved by another equation also. We already know N is equal to M into E. So we already achieved here M is equal to 0.25 and valency factor is 1. Therefore, N is equal to 0.25. So likewise, you can quickly calculate using this equation. Okay, right. Then, now let us move to the next one, that is molality. Okay, so let us consider the same thing, molality, small letter M. So molality, it is represented M, and in this case, now W2 by M2 into 1000 divided by what? W, weight of the solution. So let us consider the weight of the solution is given here as, say, weight of the solute is sodium, this is sodium hydroxide again, and same 5 gram, and molar mass we have worked out already, 40 gram per mole. Okay, and then W. So what is W? Weight of the solution. So the made up solution, its weight is, let me say that is a 500 gram. Okay, now it should be converted into 1000, kg. So what we can do, we can put M, take down, molality is equal to, let's put 5 gram weight divided by, and what about this 40 into 1, that is 1000 divided by, this is 500 gram. Okay, so now you can calculate 2, and this is 8, so 1 by 4. So the molality is equal to what? 0.25. Okay, but in this case we have to give like this 0.25 0.25, okay, 0.25 mole, you had to say per kg, remember this, okay. So this is regarding molality. Then we'll move to the next one, okay. Mole fraction is chi 2, clear, chi 2. So that is equal to n2 by n, that's all, okay. Let me say the given is there are 2 moles of sodium hydroxide and 90 moles of 90 moles of 2 moles of sodium hydroxide and 90 moles of, okay, water, H2O. Okay, you can put comfortably 98. Okay, now what is the mole fraction? So the mole fraction is, what is N2? N2 is 2 and N is nothing but N1 plus N2. So that is 100 N. Therefore you can put 100 and this is equal to 1 by 50. That is 1 by 50 means 0.2. So 0.02 mole fraction. So this is the mole fraction of the solute. So likewise, so we can calculate the entire what? Expressions of concentration. Okay, do you understand? Now, as a final part, we will discuss the valency factor. Valency factor, it is a valency means the combining capacity, is it not? The number of electrons available in the outermost shell. Okay. Now, here valency factor represents, we can do in many ways. Okay. For instance, valency factor E, we can simply put valency factor. So valency factor of an atom or a compound, we will say any OH, any compound or any salt. You can say the dominant valency should be taken. Dominant valency. Okay. So dominant valency, for instance, if it is calcium chloride, CaCl2. So the valency factor is 2 because the dominant valency for calcium is 2. So we are taken 2 as the valency factor. And for acid, it is the basicity. Basicity means how many protons are available. Okay, so the number of protons indicates here. Okay, number of H plus ions. For example, sulfuric acid. In sulfuric acid, H2SO4. So there will be 2 H plus. So it is 2, valency factor 2. For hydrochloric acid, valency factor 1. Okay. And then for phosphoric acid, H3PO4, valency factor 3, because there are 3 H. And for base, similarly, how many OH minus? So number of OH minus or acidic nature, I mean acidity of base. Similarly, basicity of acid. Okay. So number of OH minus you can put. Okay. And the best illustration for valency factor is in terms of electron. Okay. So for instance, in case of redox reactions, okay, or reducing agent or oxidizing agent, in both cases, either reduction or oxidation. So in this case, the number of electrons transferred during the reaction should be taken. Okay, number of electrons transferred, that should be taken. For example, in case of potassium permanganate, KMnO4, in that reaction its oxidation state is 7 and it undergoes reduction. Actually, oxidizing agent undergoes reduction. So it undergoes reduction. Reduction is represented by H plus. It becomes Mn plus 2. It means what? 5 electrons are transferred here. So when you calculate the potassium permanganate, okay, so what you have to do, you have to find out the equivalent mass by dividing the molecular mass by valency factor. Okay, here 5 electrons were transferred. So what you have to do, you have to divide it. Okay, so the molar mass of, let me say, what is the equivalent mass? Equivalent weight of KMnO4. How to calculate? That is molar mass of KMnO4, okay, divided by the valency factor. So here 5 electrons are responsible. Molar mass of KMnO4 is 158. So you can put 5. So that is 31.6, and that is the equivalent mass. That is, you can say gram equivalent. Okay. Do you understand? And based on that, you have to work out. For example, let us work out. Say I have say about 6.32 gram of KMnO4 dissolved and made up to 1000 ml. Okay, what is the normality? So we can find out the normality of this KMnO4. How to find out? Now listen, KMnO4, NKMnO4 is equal to W2 by M2 into valency factor divided by volume of the solution. Now let us substitute. Okay, we get that is equal to, what is W2? It is given 6.32 divided by, what about this, M2 is 158 divided into valency factor is how much, 5 divided by volume of the solution. What is volume of the solution? 1000 ml. So you can put 1 liter. So it should be converted into liter. Okay. Now the result is, that is equal to 6.32. We know 158 divided by 5. That gives 31.6. So you can multiply and divide by 100 so that the equation can be made easier. I mean, we can easily divide it. So it is 632 divided by, we can put 316 into 10. So I have taken 10. So 316 and another 10 is here. So you can comfortably multiply, I mean divide 2. Is it not? Therefore 2 by 10, that is 1 by 5. Okay, so 1 by 5, and that is 0.2 normality. Okay, so what is the normality? Normality of KMnO4 is 0.2 N, you can put, or gram equivalent or equivalent per liter. Okay, do you understand this? And I want to stress one more thing also. In case of oxalic acid, let us calculate the equivalent mass of oxalic acid. Oxalic acid, what is the formula? Oxalic acid, H2C2O4, but it contains 2 moles as laboratory agent, 2 moles of water. So you have to include that one also. So H2, hydrogen 2, carbon 12 into 2, 24, oxygen 64. Okay, so it gives what? 90. Is it not? 90. We cannot stop with that. You have to include water moles also, water molecule also. So 126. Okay, so this should be taken as what? Molar mass of oxalic acid. Are you able to follow? Now calculate, that is 6.3 gram of, take down, weight of oxalic acid is 6.3 gram, and that is dissolved and made up to 500 ml. So volume is 500 ml means 0.5 liter. Okay, then you need to calculate the normality. What is normality? So in that case, what we are to do, that is, listen, first you have to calculate the equivalent mass. What is equivalent mass? Equivalent weight is equal to molar mass 126 divided by valency factor. Valency factor is here 2. Why? Because this is COOH. This is the molecular formula of oxalic acid. So there are 2 replaceable ions. That is one aspect based on acidic nature. and when it involves in redox reaction also, it is having the valency 2. So we take 2 as a valency. So 63 is the equivalent mass, or you will follow 63. Now we can calculate, that is normality is equal to weight 6.3 gram divided by, and volume is 1 by 2, that is 0.5 into, and that is this one 63, weight by equivalent weight, is it not? So first we put that one, weight by equivalent weight, straight away you can put, so 63 into 1 by 2 we can put simply, okay, that is half liter, is it not? So multiply and divide by 10, that is the easiest way. So we can reciprocate 63 into 2 divided by 63. Okay, so into 10 by 10. You can make it as a whole number so that we will be comfortable to get accurate answers without any mistake. So 63 into 2 divided by 63 into 10. Okay, and you can strike out this, and this is 1 by 5. So 1 by 5 means 0.2. So 0.2 is the normality of oxalic acid. Do you understand? So this is the way you have to work out. Okay, I hope that is I have covered almost all types of concentration term. Let us have a quick recap whatever we have discussed. So concentration, the concentration is expressed in various ways. That is, first point, percentage, second, molarity, third, normality, fourth, molality, 5, mole fraction, 6, and this is industrially used, parts per million. Okay, and here for everything we have got the equation, you just please go through that, and you should know there is a relationship between normality and the molarity, n is equal to me, and how the percentage itself can be further divided into 3, and then solution, that is solute, solvent, how to represent that. Solute is represented as 2, solvent is 1, and we discussed various calculations based on different percentages. Okay, just go through comfortably, and you can play and you can pause wherever you want. Please take down notes, and this is one of the best that is notes for you as far as chemistry concentration, the basic concepts of chemistry is concerned. Okay, have a good plan. Thank you. Let us consider this problem based on Henry's law. If nitrogen gas is bubbled through water at 393 Kelvin, how many millimoles of nitrogen gas would dissolve in 1 liter of water? Assume nitrogen exerts a partial pressure of 0.987 bar. Henry's constant is given for nitrogen at 293 Kelvin is 76.48 kilobar. So, first of all, we will list out the given parameters. Given. What are given here? The temperature is given as T is equal to 293 Kelvin. Then how many millimoles of that is asked? So to find out. Okay, to find out how many millimoles of nitrogen. So it is asked mole. Okay, So N is asked. And this is the nitrogen gas dissolved in water. Okay, so it means it is a gas liquid solution where nitrogen is the solute, is it not? So the solute is nitrogen, and it can be represented as N2 number of moles of solute of nitrogen, W2 weight of nitrogen, and here M2 molar mass of nitrogen. So the 2 represents the one which is dissolved in small quantity, that is solute, and the liquid here is water. So water as H2O, we know the molar mass of H2O M1, number of moles N1, weight W1. So this is the sign convention we follow. And N2 exerts a partial pressure. So the partial pressure of nitrogen is 0.987. So partial pressure of nitrogen, let us indicate as 2. 2 represents here the solute in the gaseous form. So its partial pressure is given as how much? That is 0.987 bar. It is given in bar unit. And then what else is given? 1 liter would water dissolve in 1 liter. So volume of solution, volume of dissolve in 1 liter of water. So this is volume of solvent. How much? 1 liter. Okay, right. Now, what is the equation or what is the concept behind this? Henry's law. So we know already the chi2, which is nothing but the mole fraction of the gas dissolved in the gas liquid system, is equal to P2. P2 is the mole fraction of the solute, that is nitrogen here, divided by KH. How we brought this equation? This was obtained from, we know P2 is proportional to what? Chi2. Therefore, P2 is equal to proportionality constant, that is Henry's constant, into chi2. So from this equation we have brought. So you should know the original equation, and this is Henry's law. According to Henry's law, okay, this is the original equation. We are rearranged this. And chi2, what do you understand from this chi2? Chi2 is nothing but number of moles of solute divided by number of moles of solution, is it not? So total number of moles, let us say N1 plus N2, where N1 is the number of moles of solvent, N2 is the number of moles of solute. Okay, so here compared to N1, N2 is much less than N1. So N1 plus N2 is approximately equal to N1. Do you understand? And therefore we can modify this formula. Chi2 is equal to N2 divided by N1. N1 is nothing but water. So we should know the number of moles of water present in 1 liter. Okay, right. So how to calculate this? N1 is equal to weight W1 divided by, what is that? That is molar mass of solvent, that is water, is it not? Right. And this is equal to W1 is nothing but that is the given weight, is it not? So in this case it is given as 1 liter. So 1 liter means that is 1 liter of water, that is equal to V1 is equal to W1, because the specific gravity or density is equal to of water is equal to 1. Therefore, volume and weight will be equal. So it means 1 liter is equal to 1 kg, that is 1000 gram. So you can put 1000 gram. Okay, 1000 gram divided by, what is the molar mass of water? 18 gram per mole. Okay, so this is N1. Do you understand? Right. Now let us substitute everything here. So our idea is to find out the N2. Okay, so N2 is given as, let us come here. So we already know N2 is given as, we had to go from chi2. So chi2, that is the quantity required here. That is nothing but according to Henry's equation. So what is Henry's equation? P2 by kH. Okay, so P2 by kH. P2 by kH, Henry's constant. And another chi2 is equal to N2 divided by N1. So we can equate these two, is it not? Therefore, N2 by N1 is equal to P2 by kH. Therefore, N2 is equal to P2 divided by kH into N1. So we can further expand it. So P2 divided by kH is into W1 by, okay, so this is N1. So W1 divided by M1. So we can substitute here. Therefore, now N2 is equal to, we can substitute P2. So what is P2? P2 is nothing but 0.987 bar, is it not? Divided by, and what about Henry's constant value? 76.48 kilobar. So that should be converted. So you have to be very careful with regard to unit. Okay, so it is given as kilobar. Please indicate that. So this one is given in kilobar. This is kilobar. So we need to convert this into 76,480 bar. Okay, right. Now 76,480. 76,480 into, and what is W1? W1 is 1000 gram divided by M1, molar mass of solvent, that is nothing but 18. Are you able to follow? So when you work out all these things, you will get, that is 7.16 into 10 power minus 4 mole. Okay, so this is N2. Now this is asked as millimole. Milli means 10 power minus 3. Okay, so we have to convert this into millimole. That is 7 point, because they asked in millimole, into 10 power minus 1 into 10 power minus 3 mole. And this unit can be called 1 millimole. Millimole. Okay, therefore N2 is number of moles is 7.16 into 10 power minus 1 millimole. Do you understand? Or it can be written as 0.716 millimole. Got it? So this is the answer. This problem is based on the concept molality. That is one of the terms of expressions of concentration of solution. Let us get into the concept first. We know molality is represented by M, that is given by N2 divided by W. So you know N2 is nothing but W2 by M2, where W2 is weight of the solute in gram. Molar mass of the solute is represented as M2. Therefore, and what about W? W1 plus W2. In fact, these are all dilute solutions. So in the case of dilute solution, W2 is much less than W1. So in that case, we can replace W by W1. Now, we can rearrange this main equation as M is equal to W2 by M2 into 1 divided by W1. So W1 is weight of the solvent. So this is in gram, but it should be represented in kg. Okay, so probably that is W1 should be in kg, but here it may be given in gram. So in order to convert this into kg, you have to divide by 1000. Therefore, molality is equal to W2 by M2 into 1000 divided by W1. Now it is obvious that W1 is in kg. So W1, this is the weight of solvent in kg. Similarly, W2, that is weight of solute in gram. And then what about the molar mass? That is expressed as molar mass of the solute. Molar mass of solute. It is given in gram per mole. Do you understand? So with this background, we will try to explain or solve the problem. Now what is given here? A solution of glucose in water is labeled as a 10% weight by what? Weight by weight percentage. So the weight by weight percentage is given here. Okay, so let us note down the weight by weight percentage is, this is glucose. You know the formula of glucose, C6H12O6. so that immediately you can work out the molar mass of glucose that is dissolved in solvent, that is water. So molar mass means you got the carbon 6, so 6 into atomic mass is 12, so 72 plus 12 hydrogen, 12 into 112 plus, what about this? This is oxygen, so 6 into 16, that is 96. So that gives 180 gram per mole. So this is the molar mass of glucose. And the given weight of the solution, the concentration is given in weight by weight, glucose in water. So glucose is the solute, water is the solvent. So in that case, it is given as 10%. So weight by weight percent is equal to 10. So we should know the formula of a weight by weight also. So what is weight by weight percent? That is given by W2, weight of the solute present in a given amount of solution, into 100, so that we can arrive at the weight of this one, is it not? So simply we will follow the mathematical equation so that it will be very useful for you. So our objective is to find out W2 so that we can comfortably substitute here. So W2 is equal to weight into W by W percent, is it not? So we have to exchange, divided by 100. Therefore, now what is the weight of the solution? That is 100 into W by W percentage, that is nothing but 10, so that 100. So logically we can make it, this is 10, even though we know 10% means it contains a 10 gram only, but I just wanted to introduce this equation so that if it is of 10% of food, 150 gram means you should be able to work out. So that is why I worked out like this, and this is 10. So 10 gram. Now let us go back to that is molarity. So molarity is equal to, what is that? W2 by M2, is it not? So they have asked what they have asked, molality, not molarity. Okay, so you have to be very careful. Molality M, W2 by M2 into 1000 divided by W1. Now we can substitute. What is W2? W2 is 10 divided by M2. M2 is nothing but 180 gram per mole into, what about this? This is 1000, you can put, divided by W1. W1, suppose the W2 is 10 gram, W is 100 gram solution, so it should be 10, 100 minus 10, so W1 should be 90. Do you understand? So you should not put 100 here because it is W1, so I can put 90. Do you understand? Now that is equal to, you can cancel this, okay, right? So when you work out, you will get 0.617 mole per kg. But you should be aware how this unit comes. So simultaneously you can work out the unit also. So what is this? This is 10 gram. So you can put 10 gram into, that is gram. And what about this? This is number. And this one, molar mass. So gram per mole. Okay. And what about this? This is kg, is it not? So you have to put kg here. 1 divided by kg. So this can be cancelled. Now, and this is per mole, is it not? Gram per mole. So per mole, when it goes up, it becomes mole. So mole per kg. Do you understand? Mole per kg. Okay. So this is the molality. Then it is asked mole fraction also. So what is the formula for mole fraction? Mole fraction is represented as chi. This is called chi. CHI chi. Okay, mole fraction of the solute. So mole fraction of the solute is given by N2 divided by N1 plus N2. As I already suggested, N2 is much less than N1. Therefore, it is approximately equal to N2 divided by N1. So you can ignore the N1 in the denominator, N2 in the denominator, not here. Then that is equal to, now N2. N2 means what? N2 means W2 by M2. Okay. And what about N1? N1 is W1 divided by M1. So we can substitute and get the answer. So mole fraction pi 2 is equal to W2 by M2 divided by W1 by M1. That is equal to W2 divided by M2 into M1 divided by W1. Now you can suitably substitute. What is W2? 10 gram of the solute divided by molar mass of the solute is 180 gram into molar mass of solvent is 18 being water. So 18 divided by, and what about weight of the solvent? 90 gram, is it not? So 90. So you can work out. So this is 0.011. So what is the mole fraction? The mole fraction is 0.011. Okay. So mole fraction does not have unit because everything is cancelled here. So it's only a number 0.011. Do you understand? Now present the answer effectively. That is very important. Okay. So always you have to neatly present the answer. Okay. So what is the molality? Finally, you have to write molality answers. Molality is equal to how much? 0.617. Remember, mole per kg. Okay. And what about mole fraction? How to represent chi 2? That is equal to how much? 0.011. It doesn't have unit. Okay. So likewise, you can neatly present answer. Okay. So thank you for watching this video. Now let us get into the topic solubility. You please go through Shreya.
Okay.
Can you read that one? Solubility. What is solubility?
Maximum amount of the substance that can be dissolved in a specific amount of solvent at a specified temperature.
Yeah, that is, it is a maximum amount of substance that can be dissolved. So that is to maximum capacity we can dissolve. For instance, let us consider sodium chloride, and in a given amount, say about 200 ml. So in 200 ml of water, we can dissolve sodium chloride to the maximum extent. Is it not? Beyond that, we cannot dissolve. Is it not? So that level is the solubility. Beyond that, see, for instance, you can dissolve a few grams of sodium chloride in 200 ml water. You cannot take 1 kg of sodium chloride and dissolve in water. So it means the amount is restricted. Do you understand this?
Yes, sir.
Do you understand this?
Yes, sir.
கொஞ்சம் சவுண்டா பேசு. அதுக்கப்புறம் what are the factors influencing generally solution?
Nature of the solute, solvent, temperature,
pressure. Okay, so what are the different types of solution? Can you let me know?
Solid liquid solution, liquid vapor solution.
Solid liquid solution, then liquid solution, then gas liquid solution also. Okay, so gas liquid, you can call it gas liquid solution. And generally these factors are not applicable entirely for solid liquid and liquid. For instance, a pressure is not influencing, because there is no pressure, there is no compressibility factor as far as a solid and the liquid solutes are concerned. Okay, so when I ask you a question, for instance, what are the factors affecting the dissolution of solid liquid solution? If I ask you like this, then you have to tell nature of solute, solvent, temperature. And the pressure the term varadu. Is it not?
Okay.
You should not include pressure, because for solute being a solid, in this case solid liquid solution, in the case of solid liquid solution, there is no compressibility for what? Solid. Similarly, so எந்த இடத்துல pressure வந்து influencing factor? Gas liquid solution தான். இப்போ புரியுதா? So gas liquid வந்து it has more influence because gas is compressible. So அங்கதான் the Henry law அப்படிங்கிறது apply ஆகுது. Is it not? So solubility of a solid in liquid அப்படி பார்த்தோம்னாக்கா அதுல polar solvent dissolves polar solute. For instance, when you take sodium chloride, it cannot be dissolved in petrol because petrol is non-polar.
Non-polar, sir.
Sodium chloride is polar. So you cannot expect to polar. Yeah. So non-polar solvent dissolves non-polar solutes. So there is always an equilibrium between solute, solvent and solution. That is, solute combines with the solvent to give solution. That is, solute is dissolved in large quantity of solvent so that you are able to get solution. And what do you call that equilibrium? Is it a static equilibrium or dynamic equilibrium?
Dynamic.
It is a dynamic equilibrium. So saturated solution. So there are two types of solution. We can say saturated solution, unsaturated solution. Saturated solution means it is a solution in which no more solute can be dissolved at the same temperature. That is very important, and pressure. Whereas unsaturated solution means more solute can be dissolved at the same temperature. That makes the difference. Of course, concentration of the solute in saturated solution, that is called its solubility. Okay, we take some amount of solute. Okay, so based on that we dissolve it and we are able to get the required amount of what? The solution with the particular concentration. So as I already mentioned, solute and the solvent, they combine to form a solution. It is a dynamic equilibrium. Okay, right. And when we talk about the effect of temperature, the solution that is in the dynamic equilibrium follows Le-Chatelier principle. That is, it is nearly a saturated solution. The dissolution process is endothermic. In saturated solution, it is endothermic. What do you mean by endothermic? That is, heat of solution is greater than zero. அதாவது greater than zero அப்படின்னு இருந்ததுனாக்கா endothermic. That is, the temperature is absorbed here. இல்லையா? For instance, glucose எடுத்து வாட்டர்ல கரைச்சன்னு வச்சுக்கேன், அது என்ன ஆகும்? சில்லுன்னு இருக்கும். ஸோ அப்போ சில்லுன்னு இருந்தால் என்ன ஆகுது? டெம்பரேச்சரை உள்ள வாங்குதுன்னு அர்த்தம் இல்லையா? இதே இது சல்ஃபூரிக் ஆசிட் டிசால்வ் பண்ண அப்படின்னாக்கா then you are able to get that is heat and the heat evolution இருக்கும் sulfuric acidல. That is called exothermic process or dissolution or equilibrium. Okay. அதுக்கு அடுத்தது ஸோ அதனால தான் இஃப் இட் இஸ் எக்ஸோதெர்மிக் அப்படின்னா solubility வந்து எப்போதும் என்ன ஆகும் டிக்ரீஸ் ஆகிடும். ஓகே, தென் எஃபெக்ட் ஆஃப் இல்லை அது வந்து லெஸ் தேன் வரும், மாறி வரும், இங்கே தப்பாக கொடுத்துருக்கு, மாற்றிடலாம். அடுத்தது எஃபெக்ட் ஆஃப் ப்ரெஷர் அப்படிங்கிறப்போ நோ சிக்னிஃபிகண்ட் ரோல் இன் சாலிட் லிக்விட். நான் ஏற்கனவே சொன்ன மாதிரி சாலிட் லிக்விட் அண்ட் லிக்விட் சொல்யூஷனில் அதே மாதிரி லிக்விட் சாலிட் வெரஸ் ஏன் அது ரீசன் என்ன, சாலிட் ஆர் லிக்விட் அந்த புவர் கம்ப்ரெசிபிலிட்டி, அதாவது கம்ப்ரெசிபிலிட்டியே இல்லைன்னு சொல்ல முடியாது, பட் தே டோன்ட் ஹாவ் மச் கம்ப்ரெஷன் லைக் கேஸ், compressibility like gas. Then there is a significant role in gas liquid solution. So pressure has got significant role. இப்போ அதான் என்ன பண்ணோம், aerated liquid அதில் அந்த சோடா பெப்சி இதெல்லாம் பண்ணுறல்ல, அதெல்லாம் என்னது கார்பனேட்டட் வாட்டர் தானே இல்லையா? ஸோ அப்போது அந்த கேஸை வந்து கார்பன் டை ஆக்சைடு கேஸை டிசால்வ் பண்ணுறோம். ஸோ அப்போது when you apply more pressure there will be more dissolution இல்லையா? அதனால தான் ஷேக் பண்ணால் நீ தம்ஸ் அப் அடிக்கிற சர்ன்னு வெளியில் வருது இல்லை அந்த எஃபர்வசன்ஸ், இட் இஸ் பிகாஸ் ஆஃப் தட் ஒன். ஸோ ப்ரெஷரை நீ இன்க்ரீஸ் பண்ணுறதுனால கிரேட்டர் அமௌண்ட் ஆஃப் கேஸஸ் டிசால்வ் ஹியர். ஸோ ஆக்சிஜன் வந்து பார்த்தோம்னாக்கா இட் டிசால்வ்ஸ் டு ஸ்மால் எக்ஸ்டென்ட் ஒன்லி இன் வாட்டர். அது கொஞ்சமாவது டிசால்வ் ஆகிறதுனால தான் அக்வாட்டிக் லைஃப்ஸுக்கெலாம் அது ரொம்ப யூஸ்ஃபுல்லாக இருக்குது. வேற ஹைட்ரோக்ளோரிக் ஆசிட்லாம் வந்து விகரஸாக டிசால்வ் ஆகும் வாட்டரில். தென் solubility of gas generally in liquid increase with pressure. ஸோ அதை தான் ஹென்ரிஸில் என்ன சொல்கிறார் அப்படின்னா, ஹென்ரிஸில் நான் என்ன அப்படின்னு கேட்டால் டக்குன்னு இந்த ஈக்குவேஷனுக்கு வந்துடு, தட் இஸ் P is proportional to chi2. P என்ன வேப்பர் ப்ரெஷர், ஸோ வேப்பர் ப்ரெஷர் இஸ் டைரக்ட்லி ப்ரொபோர்ஷனல் டு chi2. chi2ன்றது மோல் ஃப்ராக்ஷன், Pன்றது வேப்பர் ப்ரெஷர் ஆஃப் த சொல்யூஷன். ஓகே, ஸோ அப்போ when you remove the proportionality you have to introduce a constant and that is called ஹென்ரிஸ் கான்ஸ்டன்ட். இதுதான் ஹென்ரிஸ் கான்ஸ்டன்ட் KH அப்படின்றோம். இது chi2. chi2ன்னா என்ன, எப்படி, what is the equation for chi2?
XA by XA plus X2.
So that is N2 சொல்லலாம், number of moles of solute divided by total number of moles, that is called chi2 இல்லையா? chi1ன்றது N1 divided by N1 plus N2. ஓகேவா? ஸோ அப்போ chi1 plus chi2 is equal to 1. இந்த ரெண்டு ஃப்ராக்ஷன் ஆட் பண்ணாக்க we will get 1. புரியுதா? ஸோ ஹென்ரிஸில் அந்த ஸ்டேட்மெண்ட் வந்து இந்த ஈக்குவேஷன்லேருந்தே சொல்லலாம். You just go through that statement. Henry's law is also stated that the mole fraction of the gas of the solution is proportional to the partial pressure of the gas over the solution. So இந்த இடத்துல chi2 அப்படிங்கிறது மோல் ஃப்ராக்ஷன், தட் இஸ் பார்ஷியல் ப்ரெஷர்னு சொல்லாத. ஸோ த பார்ஷியல் ப்ரெஷர் ஆஃப் த கேஸ் இன் வேப்பர் ப்ரெஷர் இஸ் அ ப்ரொபோர்ஷனல் டு மோல் ஃப்ராக்ஷன். ஸோ ஒன்னோட ஒன்று அது லிங்க் ஆயிருக்கு. அப்போது த மோல் ஃப்ராக்ஷன் ஆஃப் த கேஸ் ஆஃப் த சொல்யூஷன் இஸ் அ ப்ரொபோர்ஷன் டு பார்ஷியல் ப்ரெஷர்னு சொல்கிறான். ஸோ அப்போது இப்படியும் சொல்லலாம் அதை. therefore partial pressure, அப்போ solubility of the gas in solution அப்படிங்கிறது gas liquid solution அப்படிங்கிறது it depends on the vapor pressure. vapor pressure அதை பேஸ் பண்ணி மோல் ஃப்ராக்ஷனா, அப்போ டைரக்டா நம்ம மோல் ஃப்ராக்ஷனை அந்த இடத்துல சொல்ல முடியும். ஓகேவா? புரிஞ்சதா இது வரையிலும்? ஓகே, ரைட். Now let us continue this abnormal molar mass. Yesterday we discussed about the calculation of molar mass, that is the determination of molar mass from the colligative properties. So these are all theoretical, that is the molecular mass only. But when we examine practically with other experiments, there are some deviations. So such type of phenomenon is known as abnormal colligative property, and because of that, abnormal molar mass is obtained. Let us discuss one by one. Colligative properties generally it is determined by dilute solutions, as we already discussed dilute solutions. Okay, and these solutions they obey Rolle's law, and they are called ideal solutions. So the solutions which obey Rolle's law are called ideal solutions. But there are some deviations noticed in Rolle's law. Okay, this is because of increase in concentration of solutions. Okay, now when we consider some solution, they deviate from Raoult's law, and such type of solutions are called that is non-ideal solutions. So in the case of ideal solution, there is intermolecular force, but in spite of that, these are negligible. So in case of ideal solutions, intermolecular forces in the solvent are negligible, like in the case of ideal gas and real gas. Then, in non-ideal solution, this intermolecular forces are considerable. So there is some intermolecular force of attraction, and that is responsible for the dimerization. Now let me discuss. You know the formula of acetic acid. You think that this acetic acid formula is CH3COOH, acetic acid. And what is the molar mass of acetic acid? So let us work out CH3. There are two carbons, so 24. Hydrogen 3 plus 1, 4. And there are two oxygen, is it not? So 32. 2 into 16, 32. So how much? 4 plus 4, 8, 2, 10, balance 1, so 6. So we think that that is definitely we will get 60. But when we check the molecular weight obtained from the experiment conducted using this colligative property, it gave 120. Okay, so it means that there is some difference. Okay, so this is because of association of acetic acid. So being a dimer, this colligative property has been mistaken that is this is as a single molecule. So let us consider CH3COOH, CH3 and C double bond O, OH. And let us consider another CH3COO, okay, like this. CH3, C double bond O, OH. And this is CH3. So these two molecules, they may join due to association among themselves, okay, because of hydrogen bond. And I have indicated this by yellow line, okay. So because of this intermolecular hydrogen bonding, there is an association. Such type of liquids are called associated liquids. So this has resulted dimer. Are you able to understand? And that is why there is a difference in molecular weight. I hope now you are able to understand. So when we conduct the experiment, that is a colligative property with such kind of a molecule, we are able to get 120 as a molar mass of acetic acid. Okay, but that is truly speaking, when we work out theoretically, now it gives 60 only, is it not, from the molar, I mean molecular formula. So why there is a difference in the molar mass, and that is called the abnormal molar mass. It is because of the association. I hope now you should be able to understand this. So non-ideal solutions show deviations of incolligative properties. Are you able to understand? So from this, acetic acid is a ideal solution. Why? Because there is an intermolecular force of attraction because of intermolecular hydrogen bonding. Okay. Now, electrolytes undergo ionization in aqueous solutions. As a result, number of particles in the solution increase in magnitude. Okay, and increase in magnitude, other colligative properties increases. And colligative property and molar mass of solute are inversely proportional. Understand this point. Colligative property and molar mass, they are inversely proportional. Okay, so this is a very important point. Okay, so we will explain based on the colligative property. Okay. Then molar mass of electrolytic solutes. Okay, what is electrolyte? Electrolyte is an acid. It can be an acid or base or salt which can conduct electricity when in molten form or in solution form. So normally for electrolytes, that is like a sodium chloride solution, hydrochloric acid solution, etc., they are less than the true value. Understand this. So some solutes when dissolved in solvents may undergo association also. Okay. So they form dimers or trimers. So dimers, as in the case of acetic acid, I had explained. Okay. Right. Now, due to the association, okay, in number association number particles, due to the associated number of particles, the solution decreases. Okay, because of this, I mean, association number of particles, they decreases. Is it not? For instance, let me say there are 30 number of molecules in acetic acid. Okay, but apparently it seems to be only 15. Why? Because they dimerize. Are you able to understand? So they'll be having 15, 15 as pairs. So there is a decrease in number of solute particles. I hope now you are able to understand this. Okay. So there is a, in case of associated molecules, the number of particles in the solution decreases. I hope you are able to understand this. Then, as a result, the colligative property decreases because we have already suggested colligative property is proportional to what? The number of moles. In this case, when it decreases naturally, that is, there will be a difference in the property. Okay, right. So, molar mass of such solute will be higher than the true value. Okay, and that is why Van Hoff he introduced a very important factor that is called I in the equation in order to equalize the experimental value and the calculated value. Pi V is equal to nRT. So this is the osmotic pressure. Is it not? This is the equation for osmotic increase in osmotic pressure. So pi V is equal to RT. But we have to introduce I factor here. So therefore, what is I? The want of factor, which is nothing but the ratio between experimental colligative property and theoretical colligative property. I mean calculated colligative property. Please note down this. So this is very, very important, and there are so many questions asked based on this abnormal mass and the abnormal colligative property. Okay, so that is why here we have mentioned the experimental value of colligative property divided by calculated value of colligative property. So the ratio between them is called I factor, that is want of factor. Okay, so and when you look at in case of osmotic pressure, there will be an observed. Observed means experimental. Okay, now so that's what we have explained here. The same is repeated here. Okay, right. Now for solutes, listen to me. For solutes, how it is calculated? For solutes that undergo dissociation or ionization. For instance, in case of NaCl, that is, it gets immediately ionized, being a strong electrolyte in presence of water to become Na plus Cl minus. Okay, so that is why there is an ionization or dissociation. Okay, so on solute on such ionization, it gives n number of ions, is it not? So n number of particles. So instead of appearing 1, it appears as 2. Is it not? For example, BaCl2, it appears as 3. How? BaCl2. Okay. Now when it ionizes in presence of water, what happens? Ba2 plus Cl minus, that is 2Cl minus. So there is only one Ba2 plus and 2 negative ion. So totally 3 ion. Okay, so instead of appearing as a BaCl2, now it that is confuses the colligative property with 3 ions, and that is why we have to compensate this. Okay, so alpha is the degree of ionization because everything is accounted here. So which is responsible for ionization? Alpha is responsible for ionization because alpha is equal to 1 in the case of strong electrolyte. but it is less than 1 in case of weak electrolyte. So degree of dissociation means, or degree of ionization means what? The number of ions are produced divided by total number of ions. Okay, it indicates to what extent the ionization can take place. Are you able to understand? Right. Now, so 1 plus n minus 1 into alpha particle ions. Okay, so that has to be, that is taken into account. So let us consider an number of electrolyte is there, n number of A is obtained. So initially there was 1 and there was no product, but after certain seconds, what happens? 1 minus alpha. So the remaining is 1 minus alpha. And what about this? This is n number of alpha produced. Okay. So the total number of alpha means that is we have to add everything. So 1 minus alpha plus n alpha. So 1 minus alpha plus n alpha. And that is why we get 1 plus n minus 1 into alpha. Are you able to follow? So I is equal to the number of particles of dissociation after dissociation divided by number of particles. So in this case of dissociation, we have to highlight this. That is, what is I? Number of particles after dissociation divided by number of particles before dissociation. Okay. So therefore, number of particles after dissociation means we know already, that is I plus n minus 1 into alpha. This is after dissociation, and previously it was only 1, and that is why we had taken I as what? 1 plus n minus 1 into alpha. This is a very important equation, and where from we can calculate the degree of dissociation also based on the want of factor. So you can rearrange, for instance, that is you have I that is equal to 1 plus n minus 1 into alpha. So you can bring this I this side. So I minus 1 is equal to n minus 1 into alpha. Therefore, alpha is equal to I minus 1 divided by n minus 1, and hence the formula. Are you able to understand? So this is a very important formula, and from this we are able to calculate the degree of dissociation also. Okay, right. Now let us just look at this table. Alpha is the degree of dissociation or ionization. So for sodium chloride, the want of factor for complete ionization dissociation is 2. For potassium chloride 2, magnesium sulfate 2, K2SO4 3. Why? Because sodium chloride, sodium 1 ion, chlorine 1 ion. So 1 plus 1 2. Are you able to understand this? How we get it? Then KCl. Okay. KCl 1 plus 1, and similarly 2, and magnesium sulfate, how it is going to ionize? Mg2 plus SO4 2 minus. So each 1 ion only, is it not? So 1 plus 1 2. And what about K2SO4? K 2K plus SO4 2 minus. So it means 2 plus 1, that is 3. So that is where you have got 3. I hope now you should be able to understand this. And for associated liquids, we had to calculate like this. So n number of A, it is going to associate to become AN. So initially it was 1. After certain seconds, there is no, initially it was 1 and there was no product initially. Then after certain time, 1 minus alpha is the remaining number of moles, and here alpha by n. So total particle after dissociation means 1 minus alpha plus alpha by n. Okay. Now we get I is equal to, we have to calculate because before dissociation, after dissociation we had to divide, is it not? So before dissociation it was 1, after dissociation it was the numerator. So when we divide by 1, you get the same numerator. So I is equal to, so you can work out similarly. Okay, so this is for association. So alpha dissociation, alpha association, you should remember. Okay, so in the colligative property, we have discussed the variety of colligative properties. What are those colligative properties? Elevation of boiling point, depression of freezing point, increase of osmotic pressure, and relative lowering of vapor pressure. And we started this topic with what? The concentration, expressions of concentrations. Okay, molarity, normality, you should know something about formality also. and that is a percentage concentration, mole fraction, molality, and you should know something about the parts per million also. So these are all the various concentration terms that we discussed in this topic. And in the case of what do you call that is colligative property, we started with the derivation of elevation of boiling point, depression of freezing point, everything one by one. And we discussed in detail about osmotic pressure and what is ideal solution, non-ideal solution, and what is a Henry solution, and what are the different types of solution, solid solution, solid liquid solution, liquid liquid solution, gas liquid solution, and where the Henry's law is applicable. We are discussed in detail in this topic. Okay, so please go through this topic. Solution is one of the very important topics in chemistry, and you may come across various types of challenging questions here. So there will be a lot of numericals. So you have to practice very well. Okay. Thank you very much for watching this video. Today we will be discussing about the relationship between molarity and normality. Molarity is expressed as M. It is given by the equation N2 by V, where N2 is number of moles of solute, V is volume of solution. Then this N2 is nothing but W2 by M2. So we can replace this equation as W2 by M2 into 1 by V. And N2 is nothing but the number of moles of solute. So solute is the smaller portion of the solution. So it is represented by the subscript 2, whereas solvent is represented by 1. When I put N1, then it is called number of moles of solvent. So here V represents the volume of solution, but its unit is liter. Now let us see this molarity, how it can be represented in various ways. So you should have some convention, like that is always take 1 as a solvent, 2 as solute. So these two are present in solution. There is an equilibrium between, that is a solvent and solute to give the solution part, is it not? Then N2, when I ask you what is number of moles of solute, you should be able to tell that is the weight in gram divided by molar mass of that particular solute. Now, you know something about density. So density is equal to weight by volume. What is density? Weight by volume, or you can say mass by volume also. So its unit is gram per ml. So if it is given in gram, then it should be interpreted in terms of volume as ml. Okay, so gram per ml. Sometimes it is represented as a kg per liter also. It depends, but let us go by gram per ml. And based on that, we can find out volume, is it not? So the volume can be expressed as W by D, is it not? Where W is the weight of the solution and D the density of the solution. So, and W is, as I already mentioned, it is the weight of the solution in gram. So general convention is we represent the density in terms of gram per ml. Okay. And remember always this V is given as liter only. Okay. So if you want to give this in ml, then you should divide by 1000 because 1000 ml is equal to 1 liter. Okay. So in that case, you can divide by 1000 so that the equation becomes a W2 by M2 into 1 by V by 1000. Is it not? So this 1000 can be reciprocated. V by 1000 can be reciprocated. So that W2 by M2 into 1000 divided by V. So in this case, V represents volume in ml. You understand? Right. Okay. So this volume of the solution can also be represented by replacing this W by D, is it not? So V is equal to W by D. So you can suitably replace this volume of the solution by W by D. Okay. Now the equation becomes W by W2 by M2 into 1000 into D divided by W. You know D density in gram per ml, W weight in gram, that is weight of the solution. Okay. Then you know already M2 M2 molar mass of the solute, W2 weight of the solute. Okay. So you can straight away make it as volume as liter. So in that case, W2 is equal to M into M2 into V. So when it is given in ml, divide by 1000, otherwise leave it as such. So M into M2 into V. So this is equal to W2. So weight of the solute. So by knowing this value of molarity, molar mass and volume of the solution, you can straight away calculate the weight of the solute present, because whenever you have got some equation, there are every chance of asking questions in different ways based on the parameters they can ask. For example, if you have got 4 parameters, 3 parameters will be given and 4th parameter can be asked. Anything it can be. So weight by volume percentage is nothing but W2 by what? V into 100, where V is given in ml. Is it not? For example, when I say 5% NaCl solution means that is 5 gram is present in 100 ml solution. Is it not? Not 100 ml in water. So you had to always consider the made up solution, made up volume of the solution. Okay. Let us consider again density. You know, density is nothing but weight by volume. W by V is equal to W2 by V into 100. That is W. Now, when it is given as weight by volume percentage, you know very well W2 by V into 100. So D is equal to W by V. That is another equation. Okay. So V is equal to W by D. Therefore, M is equal to molarity that we already know, W2 by M2 into 1 by V, where V is the volume of the solution in liter. So M is equal to W2 by M2 into 1 by, here we can put V dash divided by 1000. So if it is given in ml, you have to divide this by 1000, is it not? So it becomes W2 by M2 into 1000 divided by, you can put V dash. So when I mention V dash, which is nothing but volume of the solution in ml, and V represents volume of the solution in liter. So D is equal to density, that is always given in gram per ml. So V dash, so instead of putting V, we can maintain V dash for ml. Okay, so V dash is equal to W by D. So we can substitute suitably the V dash by W by D. So M is equal to W2 by M2 into 1000 divided by, instead of V dash, you can put W by D. Okay. Therefore, M is equal to W2 by M2 into 1000 into D divided by W. Is it clear? Where W is equal to weight of the solution and D density of the solution. Okay, so by knowing the density of the solution, by knowing the weight of the solution, then the molarity of the molar mass of the, molarity of the molar mass of the solution, not solution, solute, then weight of the solute, we can determine the molarity. So based on the density also it can be interpreted. Okay. Now let us talk about normality. It is represented by N. So N is equal to EQ2 divided by P, where EQ2 represents the equivalent mass of the, that is equivalent of the solute. Like mole of the solute, we represent by N2 moles. Similarly, equivalent. Okay. What is equivalent? Equivalent is nothing but weight by gram equivalent weight. So we can replace this equation by W2 by gram equivalent weight of the solute into 1 by V. Remember, this V is in liter. So W2 by M2, and that is a gram equivalent weight is nothing but M2 by E, that is molar mass divided by valency factor. So W2 by M2 divided by E into 1 by V. So now this E is reciprocated. So you are able to get W2 by M2 into E by V, is it not? Now we already know W2 by M2 into 1 by V as M, molarity. So we can suitably replace, therefore N is equal to ME, is it not? So where E is the valency factor. Okay, E is the valency factor. So now we are able to establish the relationship between normality and molarity. Therefore, what is molarity in terms of normality? Molarity is equal to normality divided by E. That's all. Okay. Now, we should know something about the dilution. When we dilute, what happens? When we dilute a solution of particular concentration, so in terms of molarity M1, Then on dilution, on adding water or solvent, suitable solvent, it becomes what? Less, concentrated. That is, the concentration will differ. Yeah. So it becomes M2. So M1 becomes M2. So M1 V1 is equal to M2 V2. Okay. So this is the formula you should know. Where M1 is the molarity of solution 1 before dilution, you can say. Then it has become M2 means molarity changes. So molarity of the solution after dilution. It means molarity of the diluted solution. And the V1, V2, the respective volumes, is it not? So V1 is the volume of what? The solution before dilution. V2, the volume of the solution after dilution. Is it not? You would have added some water or some solvent. So there is an increase in volume. So the volume is also getting changed here. So it becomes a V2. So V1 is the volume of the solution before dilution. V2 is the volume of the solution after dilution. Okay. So based on the dilution concept also, you can anticipate some problems, some numerical problems. Okay. It will be quite interesting if you have that is a such formula already that is memorized, then it will be very comfortable for you to crack the problems. And this can also be instead of molarity, you can be asked in normality also. In that case, we have the relationship between normality and molarity. So N is equal to ME we can put. After all, in case of dilution, we'll be handling the same liquid, is it not? So there is no question arising of valency factor. So both of them will be cancelled. But in the case of, this equation, that one is for dilution and this equation is for the volumetric analysis. Okay. So it is the equation represented or very important, which has a very significant role in calculation of the strength of the given solution or experimental solution. So M1 E1 V1 is equal to M2 E2 V2. This is the equation of titration, volumetric titration. Okay, probably that is you would have been given in your practical, that is laboratory, that is potassium permanganate versus oxalic acid. So this is the redox titration. Then in the case of acid-base titration, you have sodium hydroxide versus hydrochloric acid or sulfuric acid, something like that. And you should know something about the equivalent mass also, because whenever you calculate normality, equivalent mass is also very, very important. So without that, it would be very difficult to determine the, normality. So let us find out what is normality and what is equivalent mass. We have just now discussed about normality as W2 by gram equivalent weight into 1 by V, where V is the volume of the solution in liter. Whereas a gram equivalent weight, you can express this as a gram equivalent weight, that is GEW. So being a solute, you can put a GeW2 also. So GeW is nothing but molar mass divided by valency factor. So we should know something about this valency factor. So what is this valency factor? First of all, let us try to understand what is a valency, what valency is. The binding tendency, it is the number of electrons available in the outermost shell. Okay, that decides, okay, for an element to interact, how it can be interacted with how many entities it can be interacted or develop bond. So this is the valency arrangement. So the valency factor for hydrochloric acid is 1 because it delivers H plus, 1 H plus. It's a monobasic acid. Nitric acid is also monobasic acid. Its basicity is 1. It means it is capable of delivering H plus 1. And similarly for phosphoric acid, it is 3. For sulfuric acid, it is 2. For sodium hydroxide, it's 1 because hydroxyl ion is 1. Similarly, calcium hydroxide, 2 because it has 2 hydroxyl unit. Now the valency factor, as we have already mentioned, the molar mass is very important in calculating the valency. So in that case, we have to, that is, determine which is the dominant one in a molecule. For instance, calcium chloride or barium chloride. So barium has dominant valency 2, chlorine has 1. So which should be taken? 2 should be taken. So 2 should be considered as the valency factor. So when you are asked to find out the gram equivalent mass of barium chloride, what you are supposed to do? Molar mass of barium chloride divided by 2. Okay. And for oxidizing agent and reducing agents, oxidizing agent like KMnO4, acidified KMnO4, potassium permanganate or potassium dichromate K2Cr2O7. Okay, in that case, the number of electrons transferred during the reduction or oxidation process. As you know, oxidizing agent undergoes reduction, reducing agent undergoes oxidation. So during this reduction and oxidation, how many electrons are transferred? In the case of manganese, 5 electrons are transferred because the oxidation state of manganese in KMnO4 is plus 7. So that becomes a plus 2 in MnSO4. So plus 2. So 7 becomes a plus 2 means 5 electrons are transferred here. So it should be divided by 5. Do you understand? So the gram equivalent weight for any mass, any substance is molar mass divided by the valency factor. If it is hydrochloric acid, molar mass of HCl divided by 1. If it is sulfuric acid, molar mass of sulfuric acid divided by 2. If it is potassium permanganate molar mass divided by 5. Okay. So I have once again explained here manganese on electronation, that is 5 electrons that become Mn2 plus, and that is why we divide this by 5. So it's a 5 electron transfer. Gram equivalent weight of oxalic acid. We can write oxalic acid in this way, COOH, COOH, that is H2C2O4. So usually laboratory reagent, they have 2 water molecules also. So you have to consider that one also. So H2C2O4, 2H2O. So when you calculate the molar mass, you have to include the dihydrate, 2 water molecules also. So it becomes 126 and its valency factor is 2. So the equivalent mass of oxalic acid is 63. Okay. That is 126 divided by 2. 126 is the molar mass of oxalic acid dihydrate. So when you write equivalent mass, you have to write 63 gram per equivalent. Okay. So thank you very much for watching this video. Welcome to saitechinfo channel. Today we are going to discuss about the dilute solutions, where we will be focusing on numerical problems. Okay, right. Listen. See, solutions. Under this topic, solution, generally we take into account the dilute solution as well as colligative properties are concerned. Okay? Let me consider here dilute solution. Dilute solutions. So when we say solution, the very important parameter in solution is concentration. This concentration is nothing but some solute part divided by the solution part. Solute part divided by solution part. In fact, let me consider density. What is density? This is weight by volume as far as solid is concerned. And the same thing can be applied in liquid also, any solution. Density of solution means weight of the solution divided by volume of the solution. Is it not? Right. And in the same way, concentration can be expressed as some amount of solute part divided by the volume part. But later, the weight by weight solutions are also there, and the various expressions of concentrations that is explained. For example, in the case of C, we have that is percentage solution. When I say percentage, it can be weight by weight percentage, weight by volume percentage, volume by volume percentage. Okay? And similarly, here it can be expressed in terms of molarity. M stands for molarity. So that is given by N2 by V. I will explain the formula later. And the same molarity can also be, the concentration can be explained as, expressed as molality. Molality. Molality means, that is, this is molarity, R-I-T-Y, this is L-I-T. Okay? Molarity, and this is molality. This is M, this is small m. Then we have mole fraction. What is that? Mole fraction. This is also used. Mole fraction, usually mole fraction of solute in a solution. So it can be expressed as chi2. This should be called chi2, not x2. chi2. Then we have normality. Then you have parts per million. So it means we have various expressions for concentration. Okay, various expressions for concentration. Can any one of you give the appropriate formula for each term? Anyone? I already dealt with that. You have seen in my previous videos also. Can anyone come forward? Come. If there is any problem, I will correct you. Don't worry. So you can write down the formula one by one here. First you take up weight by weight. How to proceed with the formula. Good. So what is W2?
Weight of the solute.
The sound of this. No?
Weight of the solute.
Weight of the solute. Okay. So weight of the solute. What do you mean by 2?
2 represents solute in
One.
a solution.
1.
Solvent.
Solvent. Why we are taken 2 as the subscript for solute to represent the weight of the solute as W2? Because it is a minor part. When you take solution, put solution, the solution contains 2 parts, is it not? One is solute, another is solvent. Is it not? Solute and solvent. Solute is here expressed as 2. That will be very convenient for you. Whereas the main portion is solvent, that is 1. So the major portion, right, major portion is solvent, whereas minor portion is solute. I hope now it is very clear. Okay, right. So in that case, when I say W2, weight of the solute, how to represent the weight of the solvent? W1, that's good. Similarly, molar mass of solute, how to represent that?
M2.
M2. Molar mass of solvent,
M1.
I think now based on that we can proceed. Okay. Usually weight is expressed in this case in the unit gram. Okay. And what about when I put W, what does it contain? It is the weight of solution. So weight of solute as well as weight of solution. So W is equal to W1 plus W2. So can we further modify the equation? Do it. So in the part now we are explaining only about the equations. You can erase everything. மேலே கூட வச்சிடலாம், ஃப்ரீ பண்ணிக்கோ. இது மறுபடியும் மேலே டாப்பில் எழுதிட்டு வந்துடும், ஃபுல்லாக எழுதிடலாம். அப்படியே மேலே வச்சுட்டு அதையும் வச்சிடலாம். ஸோ யூ கேன் புட் 2 columns and write down all equations clearly. Put 2 columns. Right. You please carefully follow this. Please write down. Shreya. So the first one is W by W. What is that? Weight by volume, weight by weight percentage. That is given as W2 divided by W into 100. And you have to be careful about the unit also. So what is the unit of W2? Gram. W, that is also gram. So what is the weight by weight percentage unit? It doesn't have unit. It's only percentage, that's all. Are you able to follow? So both of them are gram. And the W is equal to W1 plus W2. So you can further expand it. I hope now it is pretty clear. That is, W1 is what? Weight of the solute, solvent. Weight of the solvent. You can write down the expression on the right side. W2 is equal to weight of the, put equal to weight of the solute. W1 weight of the solvent. Is it clear? Right. Now let us move to next one. What is the next one? Weight by volume percentage. Weight by volume percentage. Shreya, can you do that? Weight by volume. Weight by volume percentage. ஜாலியாக பேசிக்கிட்டே எழுதலாமே, ஒன்றும் பிரச்சனை இல்லை. வாட் இஸ் W?
Weights.
You have to put W2. That is the solute இல்லையா? So W2 divided by V into 100. Put into mark properly. 100. Okay. Now what is the unit of your W2?
Grams.
அங்கே போடு, சைடில் போடணும். அந்த அந்த இடத்துலேயே போட்டுக்க. அந்த வெயிட் அவள் எழுதியிருக்கல அது மேலேயே கிராம்னு போட்டுக்க. வித்தின் ப்ராக்கெட் கிராம். இதுவும் கிராம் தான். இப்போ நியூ பேராமீட்டர் ஆட் ஆகுது. வாட் இஸ் தட்? What is that? Volume of the
Solution.
solvent or solution?
Solution.
Solution. Very good. So volume of the solution. Okay. Volume of the solution. That is given in ml, not in liter. In this case, it is given in ml because when you deal with the gram, it should be given in ml only. So milliliter. Always put M small letter, L capital letter to avoid confusion. நல்லா இது பிரைட்டாக இது ரொம்ப டல்லாக இருக்கு. Small m. Okay. Next. So weight by volume percentage. And what is the next percentage? Yes. Volume by volume percentage. And volume by volume percentage means V2. V2 means what? And this is feasible in the case of liquid solution. Is it not? So where the solute is also liquid, solvent is also liquid. So in that case you can make use of this one. So V2 by V. So what is V2 here? Volume of the solute in the liquid form. Now we have completed the percentage aspects. Is it clear now? Okay, right. Then we will move to molarity. What is molarity? Anyone from the boys' side? Can anyone come forward? Oh. Molarity. You go. Molarity, you can put simply M, capital M, that's all. No, write simply M, capital letter M. No, yeah, for molarity, we already explained. So put M, capital letter M, nale molarity. M is equal to இல்லை ஃபஸ்ட்டு வந்து N2ல போட்டு போடு. N2 by V இல்லை ஸ்மால் என் போடணும், அங்கே கேபிட்டல் என் வரக்கூடாது. என் அந்த மூக்கை போட அதில் ஒழுங்க. N2 by V, that's all. இப்போ இதில் N2 அப்படிங்கிறது என்ன? No. N2, number of moles of solute. N2 is equal to number of moles of solute. Number of moles of solute. Okay, right. And what is N2? Number of moles of solute. What could be the unit for that? Within bracket you can put unit. What is that? Mole. Simply mole. Okay, right. Then what is N2? Can you express N2 further? W2 by M2, is it not? So you can express this as M is equal to, again explain. M is equal to W2 by M2 into 1 by V. Got it? W2 by M2 into 1 by V. இல்லை கீழே போடு. W2 by M2 into 1 by V. Now, what is V here? Volume of what? What is the unit? Liter. Okay, so you have to be very careful. So V is equal to, in the இடத்துல V is equal to volume in solution, volume of solution in liter. Percentageல போடுறப்போ that is given in ml. Okay, you have to be very careful about this. In liter. கேபிட்டல் எல் போடு போதும். இல்லை கேபிட்டல் எல் போட்டாலே லிட்டர் தான். ஸோ சில பேர் எல்டிஆர் அதெல்லாம் போடுவாங்க, அதெல்லாம் போடாத, வெறுமனே எல் அவ்வளோதான். ஓகே ரைட். அண்ட் வாட் இஸ் W2? அது ஏற்கனவே போட்டிருக்கோம். என்னது? வெயிட் ஆஃப் த சொல்யூட். வாட் இஸ் M2? போடு. மாஸ் இல்லை, மோலார் மாஸ். கேபிட்டல் எம் போடுப்பா, கேபிட்டல் லெட்டர் எம். M2 is equal to what? Molar mass of solute. What is the unit for that? Anyone?
Gram per mole.
Gram per mole. Good. So G mole inverse. Mole inverse. Okay, got it right. Good. And can anyone write molality? On the boys' side, molality. Akash. இது அழைச்சிடலாம், அப்படியே லெஃப்டில் அழைச்சிடுது, லெஃப்ட் மட்டும். ஸோ 5th பாயிண்ட் நம்ம இப்போ போகிறது. Molality is expressed as M, small letter m. That is given by N2 by, correct?
Small m.
N2 by W, weight of the solution. ஸோ ஒவ்வொரு டெக்ஸ்ட் புக்லேயும் ஒவ்வொரு மாதிரி கொடுத்துருப்பாங்க. பட் யூ ஸ்டாண்டர்டைஸ் யுவர் செல்ஃப். உனக்கு தகுந்த மாதிரி கரெக்டாக போடும். ஒவ்வொன்றும் போடும், அடுத்தது போடும். ஸோ N2 by W இல்லையா? That W represents what? Weight of the solution as a whole. Done? போட்டுங்க, weight of the solution. W is equal to weight of the solution. It should be given in kg. So within bracket kg. Okay. Now in case of dilute solution, if W is equal to what? W1 plus W2. Is it not? Write down. W is equal to W1 plus W2. Is it not? So what is W1? Weight of the solvent. What is W2? Weight of the solution. Put together, that is the, weight of the solute. Together it is called weight of the solution. In case of dilute solution, because we are discussing only dilute solution, write down. In case of dilute solution. So you know very well, in case of dilute solution, the weight contributed by the solute is negligible. Is it not? In case of dilute solution, the weight contributed by the solute is negligible. Is it not? So W2 is much less than W1.
Less than?
Much, double less. Less na greater போடுற. W1. Therefore, in that case, W becomes W1. Do you understand? Write down. W becomes W1. Now you can represent M is equal to, write down. Small m, put always small m, is equal to, what is that? N2 by W1. Are you able to understand now? Okay. So you should know the logic. In your book they would have given straight away W1. But you should ask yourself, when I say W1, why? What happened to W2? But we are talking about dilute solution. Okay. So N2 by W1. And you can express N2 as
W2 by M.
Now work out. M is equal to, small m is equal to, put small m properly. அது எல்லாமே கேபிட்டல் மாதிரியே போடுறீங்க. அதுக்கு ஒரு மூக்கப் போட, மேலேயும் போடு, மேலேயும் சரியில்லை, அது கேபிட்டல் எம் மாதிரி இருக்காது. நீங்கள் எழுதுறதெல்லாம் உலகம் ஃபுல்லாக போகுது, பல வருஷத்துக்கும் இது இருக்கும் க்ளவுடில் இல்லையா? ஸோ W2 by M2 into 1 by W1. Now what is what is W2?
Weight of solute.
Come to the board. W2 is equal to?
Weight of solute.
Weight of solute in?
Gram.
Gram, very good. What is M2?
Mass. Molar mass of
Molar mass of?
solute.
Solute in?
Gram per mole.
That's good. And what about W1?
Weight of solvent.
Weight of solvent unit?
Gram. கேஜி.
புரியுதா? நோட் பண்ணிக்க. கேஜி. அங்கே வந்து ஒரு ஆரோ மார்க் போட்டு கேஜின்னு போட்டுக்க. வெயிட் ஆஃப் சால்வெண்ட்டு புட் ஆரோ மார்க் போட்டு கேஜி வித்தின் ப்ராக்கெட். புரியுதா? கே எப்போதும் ஸ்மால் லெட்டரில் வரணும், இல்லைன்னா கெல்வின் கிராம் மாதிரி இருக்கும். மாற்று, நீ கெல்வின் கிராம் போட்டிருக்க. ஓகேவா? ரைட். இப்படி லெஃப்டில் வந்துடுறேன். ஸோ கேஜி. சரியா? கேஜி. இப்போ W1 that is given in kilogram. If it is not given in kilogram, you had to convert it. Are you able to follow? If it is not given in kilogram, you have to convert. How to convert? You have to divide by 1000. When you divide by 1000, what will happen? It is reciprocated, so 1000 divided by W1. Are you able to follow? So write down. If the weight of solvent is given, write down. If weight of solvent is given in gram, it should be converted into kg. So in that case, divide by 1000. Upper reciprocate ஆயிடும். Now small m is equal. So இங்கே வந்து ரொம்ப கேர்ஃபுல்லாக இருக்கணும். ஓகே, m is equal to converted into if weight of solvent is given, if weight of solvent is given in gram, comma, convert into EDRS எல்லாம் convert into kg. அப்போ ஈக்குவேஷன் எப்படி மாறும்? மேலே அப்படியே போட, டாப்பில் போய்டு, அழைச்சிடு அப்படியே. ஸோ m is equal to small m is equal to W2 by M2 into 1 by அவங்க 1ங்கிறது 1000 கீழே வந்துடுது இல்லையா? ஸோ 1000 டிவைடட் பை W1. இப்போ புரியுதா? ஸோ அந்த டேர்ம் எப்போதும் கேஜியில் தான் இருக்கணும். ஓகே, ரைட். இதே மாதிரி தான் நார்மாலிட்டிலையும் அதே கேஸ் தான், மொலாரிட்டிலையும் அதே மாதிரி தான். ஓகே, இது புரியுதா? ஸோ ஐ திங்க் we have discussed in detail about the molarity. And what is the next one? Normality. யார் போடுவா? Anyone? Bharat, can you do normality? தெரியுமா தெரியாதா? போடுவியா? போடு. கம் குயிக். இது கீழே உள்ள அது என்னம்மா? 5th 6th ஈக்குவேஷனா நார்மாலிட்டி. ஆக்சுவலாக சிபிஎஸ்சியில் நார்மாலிட்டி பற்றி அதிகமாக எடுக்கிறது இல்லை, பட் யூ ஷுட் நோ. நீட்டெல்லாம் கேட்கறதுக்கு சான்ஸ் இருக்குது. இது கீழே மட்டும் அழைச்சிடு. அது லெஃப்ட்டை வண்டி அலை. அது இல்லைடா, அதுதான் லெஃப்டா. போடு. 6th பாயிண்ட் தானே? 6. Normality. How to express normality? Capital N. Normality is equal to anyone? Equivalent weight. It can be represented as EQ2. Put EQ2. Small e, small q, 2 divided by volume, capital letter V, volume of the solution. So V indicates solution, is it not? In liter, that is in liter. Okay, never forget that. Liter அங்கே ஏற்கனவே மென்ஷன் பண்ணியிருக்கோம். லீவ் இட். வால்யூம் இதில் ஏதாவது டிஃப்ரென்ஸ் இருந்ததுன்னா நம்ம மாற்றிடலாம். ஓகேவா? ஸோ வால்யூம் நீங்கள் வேணால் எழுதிக்க. அந்த வால்யூம் மேலே உள்ளதை அழைச்சிட்டு, அந்த வால்யூம் எம்எல்ல கொடுத்துருக்கோம், அதை மட்டும் அல்ல, அங்கே லிட்டர்லான்னு மாற்றிக்கலாம். விட்டுறது. ஸோ இந்த இடத்துல அதாவது பர்சன்டேஜில் மட்டும்தான் எம்எல், மற்ற இடத்துலலாம் லிட்டர் தான். அது அடுத்தது n is equal to EQ2. What is EQ2? Put EQ2 is equal to, write down. அங்கே எதுவா? இல்லை EQ2ஓட எக்ஸ்பிரஷன் EQ2 அப்படின்னு போடு. லெஃப்டில் EQ2 is equal to, what is EQ2? Anyone? Gram equivalent weight divided by valency. கரெக்டா? Anyone? ஈக்குவலண்ட் அப்படிங்கிறது வெயிட் பை கிராம் ஈக்குவலண்ட் வெயிட். எழுதிக்க. W2 டிவைடட் பை கிராம் ஈக்குவலண்ட் வெயிட். GEW. கேபிட்டல் G, கேபிட்டல் E, கேபிட்டல் Wன்னு போட்டுக்க. GEW2. புரியுதா? அப்போ வெயிட் ஆஃப் த சொல்யூட் டிவைடட் பை கிராம் ஈக்குவலண்ட் வெயிட் ஆஃப் த சொல்யூட். What is gram equivalent weight of the solute? Again, put gram equivalent weight of the solute GeW2. நீ பாட்டுக்கு W2 கேன்சல் பண்ணி வச்சிடாது. அது வந்து W2 weight of the solute, இது gram equivalent weight of the solute. So GeW2 அப்படிங்கிறது M2 molar mass of the solute divided by valency factor E. I hope now it is very clear. இப்போ இது எல்லாத்தையும் சேர்த்து உள்ளே கொண்டு வரலாம் இல்லையா? டிவைடட் பை இ, ஸ்மால் இ போடு, ஸ்மால் இ, அவ்வளோதான். ஸோ இதில் எக்ஸ்ப்ரெஸ் பண்ணிக்க எதெல்லாம் வேணுமோ போகிறதுக்கு EQ2 எழுதிக்க, ரைட்டில் எழுது, இங்கே ரைட் ஹேண்ட் சைடில் எழுது, அது ஃப்ரீயாக விடு. இங்கே காலம் இருக்குல்ல, ஃப்ரீயாக இருக்கிற காலத்தை எடுத்துடு, தேவையில்லை N2 காலி பண்ணு. N2 இங்கே இருக்கு பாரு, நம்பர் ஆஃப் சொல்யூட்டை ரிமூவ் பண்ணு, எது தேவையில்லையோ அதெல்லாம் எடு. V2 தேவையில்லை எடுத்துடு. இப்போ அந்த கேப்பில் இந்த V ரிப்பீட் ஆகிருக்கு, அதையும் ரிமூவ் பண்ணலாம். அது இருக்கட்டும், V1 V ரிப்பீட்டில் அழாத. ரைட். அடுத்தது M2, அதையும் ரிப்பீட் அழைச்சிரு. M2 அது இருக்கட்டும், சொல்யூட். அடுத்தது வெயிட் இருக்கட்டும், அங்கே வெயிட் வேண்டாம், W தேவையில்லை, அங்கே அழைச்சிரு. இப்போ எது தேவையோ அதை மட்டும் போடு பார்ப்போம். EQ2 போடு. இங்கேடா ரைட்டில் EQ2 என்ன? EQ2. What is EQ2? ஈக்குவேலண்ட் அவ்வளோதான். எப்படி மோல்னு சொல்கிறோமோ அதே மாதிரி ஈக்குவேலண்ட் அவ்வளோதான். ஸோ ஈக்குவேலண்ட் ஆஃப் சொல்யூட், ஈக்குவேலண்ட் ஆஃப் சொல்யூட். குட். அடுத்தது இல்லை, நெக்ஸ்ட்டு EQ2 போட்ட. வாட் இஸ் கிராம் GeW என்ன எழுது? கிராம் ஈக்குவலண்ட் வெயிட். இப்போ இந்த கிராம் ஈக்குவலண்ட் வெயிட் அப்படிங்கிறத நம்ம என்ன தெரிஞ்சுக்கணும். வாட் இஸ் கிராம் ஈக்குவலண்ட் வெயிட்? விச் இஸ் நத்திங் பட் மாலிகுலர் வெயிட் டிவைடட் பை வேலன்சி ஃபேக்டர். GeWன்னு போடணும், கிளியராக எழுது. கிராம் ஈக்குவலண்ட் வெயிட் GeW2, weight of the solute. இது வந்து ஒரு சிஸ்டமேட்டிக்காக கற்றுட்டுனா அங்கே யூ கேன் கண்டினியூ ஃப்ரம் ஹோம். ஸோ GeW2, put GeW2, gram equivalent weight of the solute. Is it clear? Right. அடுத்தது இங்கே இது முடிஞ்சிச்சு. நெக்ஸ்ட்டு மோலார் மாஸ், அது ஏற்கனவே போட்ட தெரியும் உனக்கு. ஈங்கிறது வேலன்சி ஃபேக்டர், ஸ்மால் இ எழுதிக்க, வேலன்சி ஃபேக்டர். இப்போ உனக்கு தெரிய வேண்டியது வாட் இஸ் வேலன்சி ஃபேக்டர். ஸோ ஸ்மால் இ இஸ் ஈக்குவல் டு எழுதிங்க இங்கே சைடில். இதை வந்து பிரான்ச் அவுட் பண்ணிக்கலாம். எப்படிலாம் போடலாம் வேலன்சி ஃபேக்டர் அப்படிங்கிறத. ஈங்கிறது பாவனி, நீ அதை எக்ஸ்பிளைன் பண்ணுமா? தெரியுமா? ஞாபகம் இருக்கா? நான் சொல்கிறேன். கிவ் இட் டு பாவனி, லெட் ஹர் எக்ஸ்பிளைன். கோ. இது எல்லாத்தையும் அழைச்சிடலாம், அதை ஃப்ரீயாக டிஸ்கஸ் பண்ணு. ஈயை பாவனி இது இப்படி திருப்பி வச்சு தொடர். நான் இ அப்படிங்கிறத வேரியஸ் இதில் எக்ஸ்பிளைன் பண்ணலாம். வேலன்சி ஃபேக்டர்னு சொல்லிட்டோம். ஃபார் ஆசிட் இட் இஸ் பேசிசிட்டி, H ப்ளஸ். அதான் ஃபார் ஆசிட் அப்படின்னு போடு. ஃபார் ஆசிட் இட் இஸ் பேசிசிட்டி, வித்தின் ப்ராக்கெட் பேசிசிட்டி. பேசிசிட்டின்னு என்ன? நம்பர் ஆஃப் H ப்ளஸ் ட்ரான்ஸ்ஃபர்ட், ரிமூவ். இப்போ HCl எழுதிக்க, அதில் பக்கத்தில் எழுது. HCl gives H ப்ளஸ் ப்ளஸ் Cl மைனஸ் இல்லையா? அப்போ H ப்ளஸ்ஸை ரவுண்ட் பண்ணு. ஸோ இட் இஸ் கால்ட் மோனோபேசிக் ஆசிட். வாட் இஸ் த வேலன்சி ஃபேக்டர் ஆஃப் HCl? 1. Why? It releases 1 H plus. Do you understand this? H2SO4. So 2H plus SO4 2 minus. Now it releases 2H plus. Upper dibasic acid. Now E is equal to 2. Write down E is equal to 1, E is equal to 2. This is for sulfuric acid. அங்கே தனியாக எழுத இல்லைன்னா ரவுண்ட் பண்ண, எல்லாம் கன்ஃபியூஷனாக இருக்குது. எழுதுறது உலகம் ஃபுல்லாக போகுது இல்லையா? ஸோ ப்ரெசன்டபுளாக கொடுங்க, அது பார்க்குறவங்களுக்கு புரியணும்ல. அடுத்தது H2 is a 4. So releases 2H plus. அப்போ E is equal to 2. Understand? Okay, ba? Suppose what is the valency factor for phosphoric acid? What is phosphoric acid? H3PO4. So 3H plus is released. அப்போ அங்கே வேலன்சி ஃபேக்டர் எவ்வளோ வரும்? 3. இப்போ புரியுதா? ரைட். நவ் இது வந்து ஃபார் ஆசிடுக்கு போட்ட. அடுத்தது E ஃபார் பேஸ். இப்போ பேஸுக்கு என்ன வரும்? அசிடிட்டி. இட் மீன்ஸ் வாட்? எவ்வளோ H ப்ளஸோட ஆட் ஆகுது, அப்படி இல்லாட்டினா எவ்வளோ ஹைட்ராக்சில் அயான் ரிலீஸ் ஆகுது அப்படி பார்க்கலாம். புரியுதா? அந்த இடத்துல என்ன ஆகும்? தட் இஸ் நம்பர் ஆஃப் OH மைனஸ் அயான் ரிலீஸ்டு, இல்லாட்டினா நம்பர் ஆஃப் H ப்ளஸ் ஆடட், எப்படி வேணால் சொல்லலாம். இப்போ ஃபார் KOH it is 1. Why? KOH gives K plus OH minus. For calcium hydroxide it is 2. Why? அது போட்டு E is equal to 1 போட்டால் போதும். அடுத்தது ஃபார் CaOH twice, calcium hydroxide. So do you understand this? Okay, right. So அப்போ E is equal to 2 here. இந்த பக்கம் இதே மாதிரி ஆசிட் பேஸ் அப்படின்னு போட்டோம். இப்போ நமக்கு வந்து இப்போ சில்வர் நைட்ரேட் அப்படின்னு ஒன்று இருக்குது. இதுக்கு வந்து எப்படி வேலன்சி ஃபேக்டர் கண்டுபிடிக்கிறது? சில்வருக்கும் Ag ப்ளஸ்ஸு, NO3க்கும் NO3 மைனஸ். அப்போ ரெண்டுத்துக்குமே ஒன்று தான் அப்படிங்கிறதுனால அதனுடைய வேலன்சி என்னவோ அதை அப்படியே போட்டுடலாம். புரியுதா? இப்போ கால்சியம் குளோரைடு அப்படின்னா அதுக்கு வேலன்சி ஃபேக்டர் எப்படி போடுறது? டாமினன்ட் வேலன்சி எது? கேட்டயான் ஆனயான்ல. ஃபார் எக்ஸாம்பிள் கால்சியம் குளோரைடு எனி மாலிகூல் அப்படின்னு போட்டுக்கலாம். அங்கேயும் போடு, ஆரமாக போடு. ஸோ கால்சியம் குளோரைடு ஃபார் எனி மாலிகூல் அப்படின்னு போட்டு கால்சியம் குளோரைடு எக்ஸாம்பிள் வச்சுப்போம். அப்போ கால்சியத்துக்கு 2 ப்ளஸ் இருக்குது. ஸோ டாமினன்ட் வேலன்சியை கன்சிடர் பண்ணணும். Therefore E is equal to 2. Do you understand? அப்போ நமக்கு இன்னொரு கொஷின் ஒன்று வரும். இப்போ let us consider KMnO4. So valency factor for KMnO4 is 5. You may ask me why. போடு. For KMnO4 it is 5. அதில் யாரை மார்க் போடு? KMnO4 E is equal to 5. Why? ஆக்சுவலாக இது எப்படி 5னு வந்தது? Now let us discuss. Potassium oxidation state 1 plus 1 put. For manganese plus 7. For oxygen minus 2. Now which is the dominant valency? Plus 7. So அப்போ நம்ம மேங்கனீஸுக்கான +7 7 தான் அங்கே போடணும். ஏன் 5 போட்டோம்? ஏன் அப்படின்னா இட் இஸ் அன் ஆக்சிடைசிங் ஏஜென்ட். அப்போது ஆக்சிடைசிங் ஏஜென்ட் ஆர் ரெடியூசிங் ஏஜென்ட்னு வந்ததுன்னா கவனி என்ன பண்ணணும்? number of electrons transferred during the reduction and oxidation. Okay, so அப்போ இது அழைச்சிடலாம் ஃபுல்லாக. ஸோ இந்த கேஸில் Mn you can put Mn I mean for oxidizing agent or reducing agent, number of electrons transferred is taken as valency factor during its reduction and oxidation respectively. You know very well, oxidizing agent undergoes reduction, reducing agent undergoes oxidation. Abde reverse. Okay, so we know what is oxidation reduction. Can you brief it? Just compare ox and reduction.
Loss of electron.
No, first to start from oxygen.
Oxygen.
Addition of oxygen.
Addition of hydrogen.
Removal of oxygen. அடுத்தது hydrogen. Next in terms of electron.
Loss of electron.
Loss of electron. So minus E. Put minus E. அங்கே லாஸ் ஆகுது இல்லை, மைனஸ் சி. இங்கே எலக்ட்ரோனேஷன், கெயின் ஆஃப் எலக்ட்ரான். அப்புறம் இன்க்ரீஸ் ஆஃப் ஆக்சிடேஷன் நம்பர், அப்வர்ட் ஆரோ ONO. இங்கே ONO போடு, இங்கே
reduction of
drop in electron, oxidation number. Okay, ferrous becomes ferric அப்படின்னா Fe2 plus becomes ferricனா oxidation அது புரியுதா. ferric becomes ferrous அப்படின்னாக்கா reduction, ஏன்னா அது oxidation number reduce ஆகுது. இன்னொன்று எப்படி சொல்லலாம், in terms of electrodic reaction,
This is
anodic, that is cathodic. So oxidation is அங்கே ஆக்ஸ்ன்னு போட்டு இந்த பக்கம் ரெட்னு போட்டுக்க, இல்லை மேலே டாப்பில் டைட்டில் ஆக்ஸ் அங்கே ரெட் நோயா ஆக்ஸ் அது ரெட். RED redனா reduction, oxனாக்கா oxidation. They occur together, that is why they are called redox reactions. Okay, right. So anodic, இங்கே cathodic, single N cathodic. இப்போ புரியுதா? Okay, right. So I was talking about the manganese reduction. Manganese is oxidizing agent, it undergoes reduction. அப்போ M1 plus 7 becomes M1 plus 5. இங்கே கீழே எழுது, M1 plus 7 becomes M1 plus 5. Now whether electrons are added or removed, added, electron is minus இல்லையா, அப்போ தானே ரிடக்ஷன் ஆகும். ஸோ புட் M1 plus 7 plus 2E, அங்கே ப்ளஸ் 2 மாதிரி ப்ளஸ் 5னு போட்டிருக்கேன். M1 plus 7 becomes M1 plus 2. ஸோ இங்கே என்ன ஆகும், ப்ளஸ் 2E, அங்கே ஏரோக்கு முன்னாடி 2E போடும், அழைச்சி போடும். ஓகேவா, இப்போ புரியுதா? ஸோ எலக்ட்ரனேஷன் அங்கே 5E 2E இல்லை, 7 2னா 5E, 5E. இப்போ புரியுதா? இந்த 5 தான் அந்த இடத்துல போடுறோம். ஓகேவா. ஸோ அப்போ வேலன்சி ஃபேக்டர் ஆஃப் பொட்டாசியம் பர்மாங்கனேட்டுன்னு கேட்டால் 5. இப்போ அதோட ஈக்குவலன்ட் வெயிட்டுக்கு நம்ம இது காப்பி பண்ணியாச்சா, அழைச்சிடு அப்படியே. ஸோ இதை வீடியோ வாட்ச் பண்ணுறவங்க கொஞ்சம் பாஸ் பண்ணி இந்த டீட்டெயிலை பார்த்துக்கோங்க. நவ் லெட் அஸ் ப்ரொசீட் ஃபர்தர். இதுக்கு அந்த ஈக்குவேஷன் என்ன போட்டேன், நார்மாலிட்டிலேருந்து வரணும், எல்லாத்தையும் ஜாயின் பண்ணி விட்டுரு. ஸோ கேபிட்டல் N இஸ் ஈக்குவல் டு என்னென்ன வரும், W2 by EQ2 டிவைடட் பை V. அதை ஃபர்தராக எக்ஸ்பேண்ட் பண்ணு. நோ அப்படியே எக்ஸ்பேண்ட் பண்ணி போயிட்டே இருக்கணும். தட் இஸ் ஈக்குவல் டு W2 by GW2 இன்ட்டு 1 by V. அதை ஃபர்தராக எக்ஸ்பேண்ட் பண்ணு, அப்படியே போட்டே போகலாம். W2 by M2 divided by V into 1 by V. ஸோ ரெசிப்ரோகேட் பண்ணிக்கோ. நாங்கள் இங்கே லெஃப்ட்டுக்கு வா, இடம் பத்தாது, இங்கே லெஃப்ட்டுக்கு வந்துருக்கோம். தட் இஸ் ஈக்குவல் டு W2 by M2 E by V அப்படின்னு வரும். நல்லா புரிஞ்சுக்கோ. இப்போ இந்த W2 by M2 எப்படி போடலாம், W2 by M2 into V into Eன்னு தனியாக போடலாம்ல, எழுதிக்க. W2 by M2 into 1 by V into E. இந்த இது வந்து நமக்கு மோலாரிட்டின்னு தெரியும். ஸோ யூ கேன் ரீப்ளேஸ் பை M கேபிட்டல் M, அது ஃபுல்லாக சேர்த்துட்டேன், இன்ட்டு E. அப்போ N இஸ் ஈக்குவல் டு கேபிட்டல் N. அப்போது நார்மாலிட்டி எப்படி கண்டுபிடிக்கலாம், நம்ம மொலாரிட்டியோட வேலன்சி ஃபேக்டரை மல்டிப்ளை பண்ணால் நார்மாலிட்டி வந்துடும். இப்போ புரியுதா? ஸோ N இஸ் ஈக்குவல் டு ME. தமிழில் வேணால் இப்படி வச்சுக்கலாம், Nன்னா எனக்கு, மீ ME, இப்படி ஞாபகம் வச்சுக்க வேண்டியதுதான், மறக்கவே மறக்காது. ஓகேவா, கரெக்ட் தானே நான் சொன்னது? N மீ. ஸோ எப்படி ஞாபகம் வச்சுட்டேன்னா, ஆனால் நமக்கு வேணுங்கிறது எக்ஸ்ட்ராக்ட். ஸோ N இஸ் ஈக்குவல் டு M இன்ட்டு E. புரியுது? அப்போ Mன்னா மொலாரிட்டி, Nன்னா நார்மாலிட்டி, Eன்னா வேலன்சி ஃபேக்டர். இப்போது பொட்டாசியம் பர்மாங்கனேட் நல்லா ஞாபகம் வச்சுக்க. பொட்டாசியம் பர்மாங்கனேட் இல்லாட்டினாக்கா ஈவன் சல்ஃபூரிக் ஆசிட் எடுத்துப்போம். சல்ஃபூரிக் ஆசிடில் வாட் இஸ் த வேலன்சி ஃபேக்டர் பார்த்தோம், 2. கேன் யூ ஒர்க் அவுட் தி equivalent mass of sulfuric acid, that is gram equivalent weight of sulfuric acid? What is the formula? So code GEW of sulfuric acid. Order 2 போடலாம் தப்பு இல்லை. Of H2SO4 இப்போ அதுதான் ஒர்க் அவுட் பண்ணுறோம். எப்படி பண்ணலாம்? மாலிகுலர் வெயிட் டிவைடட் பை வேலன்சி ஃபேக்டர் தானே இல்லையா? ஸோ வாட் இஸ் த மாலிகுலர் வெயிட் ஆஃப் சல்ஃபரிக் ஆசிட்? 98 டிவைடட் பை வேலன்சி ஃபேக்டர் எவ்வளோ? 2. அப்போ அதோட மாலிகுலர் இது எவ்வளோ? 49. இப்போ புரியுதா? இப்போது உங்களுக்கு ஸ்கூலில் கூட சொல்லி கொடுத்துருப்பாங்க. அதாவது ஆக்சாலிக் ஆசிடோட மாலிகுலர் ஈக்குவலன்ட் வெயிட் 63 ஞாபகம் வச்சுக்கோ. அது எப்படி வந்தது? ஆக்சுவலாக let us work out. Gram equivalent weight of oxalic acid. What is the formula of oxalic acid? H2C2O4. பட் அதோட நிப்பாட்ட முடியாது. ஏன்னா அனலார் ரியேஜென்ட்டில் வந்து 2 moles of water இருக்கும். ஸோ 2H2O. oxalic acid 2H2O சேர்த்து போடு 2H2O. இப்போ அதை ஒர்க் அவுட் பண்ண வாட் இஸ் த மாலிகுலர் வெயிட்? 126. So 126. இப்போ oxalic acidல replaceable hydrogen வந்து 2, and not only that, that undergoes reduction, oxidation. அங்கேயும் 2 electron transfer ஆகும். புரியுதா? ஸோ அப்போ அந்த கேஸில் என்ன ஆகுது? 2 valency factor. அப்போ 126 divided by 2. So that is equal to 63. I hope now you should know how it has come. Okay, 63. So this is regarding another gram equivalent weight. இப்போ இந்த நார்மாலிட்டியை எப்படி கொடுத்தா மாற்ற தெரியும்? இது எல்லாமே கால்குலேஷனில் நம்ம இறங்குவோம். இது எங்கே யூஸ் ஆகுனாக்கா உங்களுடைய ஜேஇஇ நீட் இதில் இந்த மாதிரி கால்குலேஷன்லாம் நிறையா வரும். யூ ஹேவ் டு பி வெரி கேர்ஃபுல். அது நம்ம நெக்ஸ்ட் கிளாஸில் பார்ப்போம். அண்ட் லாஸ்ட்டாக மோல் ஃப்ராக்ஷன். யூ பண்ணுற மோல் ஃப்ராக்ஷன், மோல் ஃப்ராக்ஷன், ஃபைனலி மோல் ஃப்ராக்ஷன். கம் ஸ்ரீநிதி. கிட்ட நீங்கள் வேறு சாக் எடுத்துக்கோங்க. மோல் ஃப்ராக்ஷன். ஒரு காலத்தில் எல்லோரும் ப்ரொஃபஸர் ஆகிடுவீங்க. இந்த போர்டை டச் பண்ணவங்க அத்தனை பேரும். மோல் ஃப்ராக்ஷன், ஹவு டு ரெப்ரசன்ட் தட்? கைன்னு போடணும். புக்கில் எக்ஸ் மாதிரி போட்டிருப்பான், பட் கை அது கை 2 சொல்லிவிட்டுக்கு தான் போடணும். 2 நல்லா போடு. கை 2. Good. So total number of moles N2 divided by N1 plus N2, and N1 plus N2 can be N அப்படின்னு வச்சுக்கலாம். அண்ட் சில கேஸ் இப்போ அதே மாதிரி தான் கன்சிடரிங் டைல்யூட் சொல்யூஷன். அப்போ N2 இஸ் நெக்லெக்ட்னா மேலே உள்ளதையும் சொல்லிவிடக்கூடாது, அடிஷனில் தான் நெக்லெக்டட். அப்போ இன் கேஸ் ஆஃப் டைல்யூட் சொல்யூஷன் யூ கேன் புட் சிம்பிளி N2 by N1 அப்படின்னு போடலாம். இன் கேஸ் ஆஃப் வெரி டைல்யூட் சொல்யூஷன் that represents N2 by N1 அப்படின்னு போடலாம். ஸோ யூஸ்வலாக N2 by N அப்படின்னு போடலாம். ஓகேவா? அது அந்த எந்தெந்த கேஸ் கன்சிடர் பண்ணுமோ அதுக்கு தகுந்த மாதிரி தான். N2 is much less than N1. Therefore, N2 by Chi2 is equal to N2 by N1 போடலாம். In case of dilute solution, condition வந்து dilute solution. ஓகேவா? இது புரியுதா? டைல்யூட் சொல்யூஷன். பார்ட்ஸ் பர் மில்லியன் யார் போடுவா? Chi1 அது அந்த ஒரு ஈக்குவேஷன் இருக்குது. Chi1 + Chi2 is equal to 1 இல்லையா? பார்த்து Chi1 + Chi2 கையை ஒடிச்சுக்காத. Chi1 + Chi2 is equal to 1. அப்போது if you know Chi2 you can find out Chi1 also. 1 minus Chi2. ஓகேவா? ரைட். பார்ட்ஸ் பர் மில்லியன் வா, தெரியுமா? சீக்கிரமா அபிஷேக், கம் குயிக், chi2 mole fraction. இப்போ ppm
ppm
parts per million. ppm is equal to, do it fast. ppm, can anyone guide him? உனக்கு தெரியுமா போகிறதுல போடு நீ. அது ஏன் 10 power 6 போடுறோம்? மில்லியன் பர் மில்லியன் அப்படிங்கிறதுனால. அவ்வளோதான். ஸோ வெயிட் ஆஃப் த சொல்யூட் டிவைடட் பை டோட்டல் வெயிட் ஆஃப் த சொல்யூஷன். அது கிராம், இதுவும் கிராம் தான், பட் மில்லியனில் இருக்கும். ஸோ ppmனு போடுவோம். இது எங்கே? த டோட்டல் ஹார்ட்னஸ், டெம்பரரி ஹார்ட்னஸ், பர்மனன்ட் ஹார்ட்னஸ், இது மாதிரி ஹார்ட்னஸ் ஆஃப் வாட்டர் இருக்கிறப்போ அது ரொம்ப டைல்யூட்டாக இருக்கும். அதனால் ஹார்ட்னஸ் ஆஃப் வாட்டர் வந்து இதில் ppmனு போடுவாங்க. இண்டஸ்ட்ரீஸில் these terms are very popular. So let us finalize this class by summarizing. You know what is colligative property? Okay, you can go. What is colligative property? Colligative property na enna? Can anyone tell me colligative property? Okay, let us have a general discussion. You can continue. What is colligative property? Anyone? Don't I can do. What is colligative property? யாருக்கா தெரியுமா? நம்ம நிறைய படிச்சிருக்கோம். What is colligative property? ரெண்டு டிஃபரன்ஸ் இருக்கு. What is colligative property? What are colligative properties?
Colligative properties are relative lowering of vapor pressure. Different.
இல்லை நீ சொல்கிறது எக்ஸாம்பிள். நீ சொல்கிறது என்னென்னா வாட் ஆர் colligative properties அப்படின்னா increase elevation of boiling point. There you go. What are colligative properties அப்படின்னா increase of boiling point. Next increase of BPT போடு, ஷார்ட் ஃபார்மில் போடு. அடுத்தது அதை எப்படி ரெப்ரசன்ட் பண்ணுறோம்? டெல்டா டிபி பக்கத்தில் இது வித்தின் ப்ராக்கெட் டெல்டா டிபி. அண்ட் நெக்ஸ்ட்டு டிக்ரீஸ் ஆஃப் ஃப்ரீசிங் பாயிண்ட். அதை டிப்ரெஷன் ஆஃப் ஃப்ரீசிங் பாயிண்ட் சொல்கிறோம். டிப்ரெஷன் ஆஃப் ஃப்ரீசிங் பாயிண்ட். டிப்ரெஷன் சரியாக ஸ்பெல்லிங் இல்லைன்னா மரியாதை டிக்ரீஸ்ன்னு போட்டுக்கணும். டிப்ரெஷன் ஆஃப் ஃப்ரீசிங் பாயிண்ட் நினைச்சேன். ஸோ டிப்ரெஷன் ஆஃப் ஃப்ரீசிங் பாயிண்ட். ஓகே, next decrease of freezing point. Power is very safe. Then relative lowering of vapor pressure. Okay, carry on. Relative lowering of vapor pressure. What is relative lowering of vapor pressure? அது வந்து delta TF. இது relating RLVP னு ஷார்ட் ஃபார்ம்ல போடுங்க. So relative lowering of vapor pressure ன்றது என்ன? Vapor, what is vapor pressure? It is a hidden pressure of the solution. இப்போ பியூர் சால்வெண்ட்டுக்கு வேப்பர் ப்ரெஷர் ஒன்று இருக்கும். அதில் எதையாவது சால்ட்டை கிட்ட போட்டோன்னு வச்சுக்கேன், என்ன ஆகிடும்? ரெடியூஸ் ஆகிடும் இல்லையா? இப்போ ப்ரெஷர் அப்படின்னா என்ன? இப்போ இந்த ரூமில் எத்தனை பேர் இருக்கீங்க? 2, 4, 6. ஸோ சோசியல் டிஸ்டன்ஸை கன்சிடர் பண்ணி ஒவ்வொரு பெஞ்சிலையும் 2 கொஞ்சம் தள்ளி உட்காருங்கப்பா. சோசியல் டிஸ்டன்ஸ் மெயின்டைன் பண்ண வேண்டாமா? அபிஷேக் ஓகே. ஸோ பாவம் நீங்கள் தனியாக சேஃபாக நிற்கிறா இல்லையா? ஸோ அப்படிங்கிறப்போ நாம் தனித்தனியாக இருக்கோம், அதனால் சேஃப் ஜோனில் இருக்கோம். ப்ரெஷர் இல்லாமல் இருக்குது. ஆர் ஏபிள் ஃபாலோ? ப்ரெஷர் இல்லை, அது தெரியலையா? ப்ரெஷர் இல்லாமல் இருக்குது இல்லையா? இப்போ ப்ரெஷர் ஓரளவு ப்ரெஷரில் இருக்குது. இப்போ நான் ஏதாவது ஆட் பண்ணணும்னு இப்போ அதாவது வாட் டு யூ மீன் பை ப்ரெஷர்? ஃபர்ஸ்ட் ஆஃப் ஆல் டெல் மீ. ப்ரெஷர், அது ப்ரெஷர்ன்றது தட் இஸ் த டேர்ம் அசோசியேட்டட் வித் த கேஸ். அது ரொம்ப அதிகமாக நம்ம சொல்லுவோம். இல்லை ப்ரெஷர் அப்படிங்கிறது என்னது? நோ, ஃபோர்ஸ், மாஸ் ஏரியா, ஃபோர்ஸ் ஆக்டிங் ஆன் யூனிட் சர்ஃபேஸ் ஏரியா. அதாவது ப்ரெஷர் அப்படிங்கிறது இட் இஸ் பிகாஸ் ஆஃப் த collision among themselves, collision of molecules among themselves or with the wall of the container. நான் சொல்கிற பாயிண்ட் புரியுதா? வால் ஆஃப் த கண்டெய்னர். இது வந்து ப்ரெஷர். இதே மாதிரி கேஸில் இருக்கிற மாதிரி வேப்பர்லையும் இருக்குது. வேப்பரில் இருக்கிற மாதிரி லிக்விட்லேயும் இருக்குது. அது ஹிடனாக இருக்குது. தட் இஸ் லெஸ் தேன் அட்மாஸ்பியரிக் ப்ரெஷர் நார்மல் லிக்விடில். நல்லா புரிஞ்சுக்கோ. ஸோ திஸ் இஸ் கால்ட் வேப்பர் ப்ரெஷர் ஆஃப் அ லிக்விட். புரியுதா? ரைட். இப்போ என்ன ஆகிடும் அப்படின்னா, இங்கே எதையாவது எக்ஸ்டர்னலாக நம்ம வந்து இன்ட்ரடியூஸ் பண்ணி விட்டோம்னு வச்சுக்கோ, ஒரு ஸ்மால் அமௌண்ட் ஆஃப் சொல்யூட்டை இன்ட்ரடியூஸ் பண்ணால் வேப்பர் ப்ரெஷர் லோயர் ஆகிடும். இப்போ நம்ம எலிவேஷன் ஆஃப் பாய்லிங் பாயிண்ட் பற்றி பேசணும். வாட்டருக்கு பாய்லிங் பாயிண்ட் 100 டிகிரி சென்டிகிரேட். அதில் கொஞ்சோண்டு ஏதாவது ஒரு சொல்யூட்டை இன்ட்ரடியூஸ் பண்ணி விட்டோம்னாக்கா என்ன ஆகிடும்? எலிவேட் ஆகிடும் பாய்லிங் பாயிண்ட் 100 டிகிரி. நீ எதிர்பார்க்குற மாதிரி 100 டிகிரி உடனே 200 டிகிரி எல்லாம் மாறாது. மாறுதெல்லாம் ரொம்ப கம்மியாக தான் வரும். ஸோ 100.03 அப்படின்னு வரலாம். அது மாதிரி ஒரு மார்ஜினில் எலிவேட் ஆகும். 100.1 100.2 அப்படின்னு எலிவேட் ஆகும். இதை தான் எலிவேஷன் ஆஃப் பாய்லிங் பாயிண்ட் ஆகும். இந்த எலிவேஷன் எதனால்? பிகாஸ் வேப்பர் ப்ரெஷர் லோயர் ஆகிடும். ஸோ அப்போ அந்த லோயர் லெவல்லேருந்து பிக்கப் பண்ணி கொண்டு போகிறதுக்காக எக்ஸ்ட்ரா டெம்பரேச்சர் தேவைப்படுது. நான் சொல்ல பாயிண்ட் புரியுதா? ஸோ அதுதான் இங்கே லோயரிங் ஆஃப் வேப்பர் ப்ரெஷர் அப்படின்னு சொல்லிட்டு. அதுக்கு அடுத்தது நெக்ஸ்ட்டு osmotic pressure. How to introduce osmotic pressure? That is given as pi. So I can put pi. Pi is equal to osmotic pressure. Okay, well, so what is osmosis? Two different concentrated liquids.
Which flows from
அதை செப்பரேட் பண்ணி வச்சோம் ஒரு செமி பர்மியபிள் மெம்பரேனில். என்னாகும்? லோயர் கான்சன்ட்ரேஷன்லேருந்து ஹையர் கான்சன்ட்ரேஷனுக்கு சால்வன் மாலிகூல்ஸ் ட்ரான்ஸ்ஃபர் ஆகும். நல்லா புரிஞ்சுக்கும். அப்போது வேப்பர் ஆஸ்மாட்டிக் ப்ரெஷர்ன்றது அந்த அதர் சைட்லேருந்து நம்ம ஒரு ப்ரெஷரை எக்ஸர்ட் பண்ணோம்னா we can prevent the entry of solvent molecules இல்லையா? thereby we can arrest the solvent transfer. ஓகே, அது எப்படி வேணால் எடுத்துக்கலாம். இந்த பக்கத்துலேருந்து அரெஸ்ட் பண்ணோம்னாக்கா ஆஸ்மாசிஸ் ஸ்டாப் ஆகும். அந்த பக்கத்துலேருந்து டிக்ரீஸ் பண்ணோம்னா ஆஸ்மாசிஸ் இன்க்ரீஸ் ஆகும். எந்த பக்கத்தில் நின்று பண்ணுறோம் அப்படிங்கிறது தான் என்ட்ரி அப்படிங்கிறது. பிளாக் பண்ணுறோமா இல்லாட்டினாக்கா இன்னும் கொஞ்சம் சக் பண்ணுறோமான்றது. ஸோ தட் இஸ் ஆஸ்மாட்டிக் ப்ரெஷர். இது வந்து இன்க்ரீஸ் ஆஃப் ஆஸ்மாட்டிக் ப்ரெஷர். நோட் பண்ணிக்கோ, இன்க்ரீஸ் ஆஃப் ஆஸ்மாட்டிக் ப்ரெஷர். தீஸ் ஆர் ஆல் கால்டு கொலிகேட்டிவ் ப்ராப்பர்ட்டிஸ். ஸோ ஒவ்வொன்றுத்துக்கு ஈக்குவேஷன் போட முடியுமா? டெல்டா டிபி இஸ் ஈக்குவல் டு வாட்? கேபி இன்ட்டு delta TB is equal to KB into
W2 by M.
no. So you can simply put what? Mole fraction la போடலாம்ல, molality la போடலாம், small m. அதானே?
molality, yes sir.
அடுத்தது
delta TF equal to K.
அங்கே ஒரு ஏதாவது கோடு வீடு போடலாம், எல்லாம் சேர்ந்துட்டு இருக்குது. So delta TB is equal to what? KB into small m. Second equation, delta TF is equal to KF into, but delta K, KB na molar elevation constant. It is also known as ebullioscopic constant. Actually நம்ம என்ன பண்ணுவோம், பாயிலிங் அப்புறமேட்டு வேப்பரைசேஷன் இல்லாட்டா எவாபரேஷன் இப்படிலாம் சொல்லலாம் இல்லையா? இதுக்கு ஒரு காமனான வேர்டு இருக்குது, அது என்ன? எபுலிஷன் அப்படின்னு பேர். அதனால் அந்த கான்ஸ்டன்ட் பேர் எபுலியோஸ்கோபிக் கான்ஸ்டன்ட். அடுத்தது இல்லாட்டா மோலால், LAL, மோலால் எலிவேஷன் கான்ஸ்டன்ட். நெக்ஸ்ட்டு மோலால் டிப்ரெஷன் கான்ஸ்டன்ட், அண்ட் இட் கேன் ஆல்சோ பி கால்டு கிரையாஸ்கோபிக் கான்ஸ்டன்ட். இப்போ இந்த ராக்கெட் இன்ஜின் இதெல்லாம் கிரையாஸ்கோபிக் லேபரேட்டரியில் இதெல்லாம் பண்ணுறாங்களே ஃபியூல்ஸ்லாம். ஸோ கிரையாஸ்கோபிக் கான்ஸ்டன்ட் பேர். வாட் இஸ் தட்? KF அப்படிங்கிறது. ஸோ அடுத்தது
relative lowering of vapor.
VP is equal to mole fraction. இல்லை, what is delta P divided by P naught? Delta P divided by P naught is equal to chi 2. ஸோ மோல் ஃப்ராக்ஷனை பேஸ் பண்ணி தான் அது இருக்கும்னு சொல்கிறான். டெல்டா பின்றது என்ன? P naught minus P. நாட்னு அந்த இடத்துல என்ன?
Pure sir.
அது அப்படியே போட்டுட்டேன். P naught minus P divided by P naught is equal to chi 2. Straight up. So P naught minus P divided by P naught is equal to, what is that? Chi 2. Chi 2 என்ன? Mole fraction. P naught pure solvent.
Pure solvent.
P அப்படிங்கிறது சொல்யூஷனோட வேப்பர் ப்ரெஷர். அப்போ மேலே நியூமரேட்டர் எப்படி சொல்கிறது? லோயரிங் ஆஃப் வேப்பர் ப்ரெஷர். இந்த ரேஷியோவை எப்படி சொல்கிறது? திஸ் லோயரிங் ஆஃப் வேப்பர் ப்ரெஷர் டு த ஒரிஜினல் வேப்பர் ப்ரெஷர், தட் இஸ் P naught. அதை தான் ரிலேட்டிவ் லோயரிங் ஆஃப் வேப்பர் ப்ரெஷர் சொல்லுது. இப்போ புரியுதா? ரைட். நெக்ஸ்ட் ஆஸ்மாட்டிக் ப்ரெஷர் பை இஸ் ஈக்குவல் டு CRT. அது வந்து எதை பேஸ் பண்ணி அந்த ஐடியல் கேஸ் ஈக்குவேஷனை பேஸ் பண்ணி நம்ம சொல்லுவோம். ஓகே, ஸோ பை இஸ் ஈக்குவல் டு சிஆர்டி. வாட் இஸ் பை? ஆஸ்மாட்டிக் ப்ரெஷர். சி கான்சன்ட்ரேஷன். அதை எப்படி போடுவோம்? N2 by V போடலாம்ல, போடு. ஸோ பை இஸ் ஈக்குவல் டு N2 by V RT. இப்போ ஒவ்வொன்றுத்துலேயும் நம்ம வருவோம். KB, இந்த கேபியை நான் தூக்கினேன்னு வச்சுக்கேன், புரியுதா? கேபி எடுத்தோம்னாக்கா அங்கே என்ன ஆகும்? ப்ரொபோஷ்னாலிட்டி வந்துடும் இல்லையா? ரிமூவ் பண்ணு, கேபியை ரிமூவ் பண்ணிட்டு ப்ரொபோஷ்னாலிட்டி போடும். ஸோ வென் யூ ரிமூவ் அ கான்ஸ்டன்ட், ப்ரொபோஷ்னாலிட்டி அரைசஸ். அடுத்தது அதே மாதிரி டிஎஃப்க்கும் ப்ரொபோஷ்னல் டு எம். ஸோ டெல்டா டிஎஃப் இஸ் ப்ரொபோஷ்னல் டு எம். அதே மாதிரி இந்த இடத்துட்ட N2 by N1, N2 by N தானே, கை டூங்கிறது, தட் இஸ் ஈக்குவல் டு N2 by N. அந்த சிடிக்கு இங்கே போட்டோம் இல்லையா? இப்போ எம்முனா நம்ம என்ன பார்த்துருக்கோம்?
M வந்து W2 by W.
இல்லை, ஸ்மால் எம் N2 by W
N2 by W பேசு
இல்லையா? N2 by W. அதை கிராமில் மாற்றுறது இருந்தால் 1000 அதெல்லாம் போடுறோம், அதெல்லாம் நமக்கு தேவையில்லை. ஸோ அப்போது எம் அப்படிங்கிறத ரீப்ளேஸ் பண்ண இப்போ N2 by W, that is W1 in this case. So N2 by W1. இங்கே N2 by W1. இப்போ எல்லா கேஸ்லையும் நான் சொல்யூஷனை கான்ஸ்டண்ட்டாக வச்சுக்கிறேன்னு வச்சுக்கேன், புரியுதா? அப்போ இங்கே நம்பர் ஆஃப் மோல்ஸ் மட்டும்தான் மாறுது. நான் சொல்ல பாயிண்ட் புரியுதா? அப்போது கொலிகேட்டிவ் ப்ராப்பர்ட்டின்றதுக்கான டெஃபினிஷன் இங்கே கிடச்சிருது இல்லையா? இது எது மாறுது? 2 அப்படிங்கிறது மாறுறதுனால மற்ற எல்லாம் கான்ஸ்டன்ட் தானனால. இப்போ இந்த கடைசி ஈக்குவேஷன் பாரு, ப்ரொபோஷனல் டு N2 தான். V எல்லாம் தூக்கிடு, பை இஸ் ப்ரொபோஷனல் டு N2. மற்ற எல்லாத்தையுமே சிஆர்டி எல்லாம் கேன்சல் பண்ணிட்டு வெறுமனே N2 மட்டும் போடு, ப்ரொபோஷனல் டு N2. இப்போ ஃபஸ்ட்டு ப்ராப்பர்ட்டி டிக்கடி, அது எதை பேஸ் பண்ணியிருக்கு? இல்லை, அந்த இடத்துல டெல்டா டிபிலே போடு. எதை பேஸ் பண்ணியிருக்கு? N2வை பேஸ் பண்ணியிருக்கு. ரவுண்ட் பண்ணு N2வை. அடுத்த செகண்ட் ப்ராப்பர்ட்டி எதை பேஸ் பண்ணியிருக்கு? N2 போடு, டிக் பண்ணு டெல்டா டிஎஃப். தேர்ட் ப்ராப்பர்ட்டி அதாவது RLYP, ரிலேட்டிவ் லோயரிங் ஆஃப் வேப்பர், எதை பேஸ் பண்ணியிருக்கு? N2 போடு, ப்ரொபோஷனாலிட்டி போடு. அங்கேயும் அந்த எண்ணெய் எடுத்துருவோம். ஓகேயா? ஸோ அந்த எண்ணெய் எடுத்துரு. அடுத்தது இங்கே பை, அந்த பை சிஆர்டியை தூக்கிட்டு வெறுமனை பை வண்டி வச்சுக்கோ. ஸோ பை அந்த ப்ராப்பர்ட்டியை டிக் பண்ணு. அது எதை பேஸ் பண்ணியிருக்கு? இது எல்லா ப்ராப்பர்ட்டியுமே நல்லா பார்த்துக்கோ, ஃபிசிக்கல் ப்ராப்பர்ட்டி தானே, கெமிக்கல் ப்ராப்பர்ட்டி இல்லை. அப்போது த ஸ்மால் சேஞ்ச் அப்சர்வ்டு இன் டைல்யூட் சொல்யூஷன் இன் த ஃபிசிக்கல் ப்ராப்பர்ட்டிஸ், they are based on the amount of solute present. That is called colligative property. இப்போ டெஃபினிஷன் கிடச்சிதா? ஸோ வாட் இஸ் colligative property na? Colgate property இல்லை, colligative property. So what is colligative property? It is the phenomenon of change of physical property. இப்போ அந்த டெஃபினிஷன் புரியுதா? It is the phenomenon of change of physical property that depends on the amount, physical property of the solution, the change of physical properties of solution with respect to the change in the number of moles of solute. Okay va? With respect to the change in the amount of solute அப்படின்னு கூட வச்சுக்கலாம். amount of solute, amount இந்த இடத்துல நம்ம நம்பர் ஆஃப் மோல்ஸில் சொல்லலாம், வெயிட்டில் சொல்லலாம், இப்படி வேணாலும் சொல்லலாம். இப்போ புரியுதா? ஸோ இதுக்கு டெஃபினேஷன் கிடச்சிதா? இப்போ எல்லா ப்ராப்பர்ட்டிக்குமே ரேஷியோ போட தெரியணும். உனக்கு கேட்குறதெல்லாம் எல்லாம் அந்த மாதிரி கேட்கலாம். நான் ஏற்கனவே அந்த மாதிரி மேப்பிங் பண்ண சொல்லியிருக்கேன். எந்த ஈக்குவேஷன் இருந்தாலும் புரியுதா, ஒரே மாதிரி கொடுத்துட்டு 2 கொஷினை கேட்கலாம். அந்த ரேஷியோ எவ்வளோ அப்படிங்கிறதையும் கேட்கலாம். ஓகே, ஸோ தேங்க்யூ ஃபார் வாட்சிங் திஸ் வீடியோ அண்ட் ஐ திங்க் ஷி ஹஸ் எக்ஸ்பிளைன்ட் வெரி நைஸ்லி. ஸோ திஸ் இஸ் த என்டையர் திங். ஐ திங்க் இந்த பார்ட்டை நம்ம காமிக்க விட்டாச்சு. ஓகே, இது கொஞ்சம் எக்ஸ்பிளைன் பண்ணிவிடு, ஏன்னா அவங்க மற்றவங்க தெரியாது. பிக்கப் பண்ணி
colligative properties it consists of increase of boiling point, decrease of freezing point. An increase of boiling point is represented as delta TB, decrease of freezing point is represented as delta TF. Next is relative lowering of vapor pressure, and the last one is osmotic pressure, increase of osmotic pressure. So generally the definition of colligative property is phenomenon of change of physical property of solution with respect to change in the amount of solute. So the equation for increase increase of boiling point is delta TB is directly proportional to N2 by W1. If we remove the proportionality, the constant introduced there is Kb. And next, delta Tf is directly proportional to N2 by W1. Here the constant introduced is Kf. Here P0 minus P by P0 is directly proportional to the
Number of moles of solute.
number of moles of solute.
Okay.
That is chi2, and here N2 is negligible. So N2 by N1. So N2 is directly proportional to this ratio. And the last one, osmotic pressure, pi is directly proportional to N2.
Okay, very good. Okay, so I hope you should have enjoyed this lecture, and we will continue in the next class. Thank you very much.